have one more really awesome capstone project in this course, and so that's what we'll be gearing up for next. Everything in this course has culminated up to this final capstone project called Assembly Endgame. In this game, you are fighting the forces of evil to try and save the world's programming languages from being extinguished, only leaving the assembly language left. Okay, let's be real, it's just a rebranded version of Hangman. But instead of drawing a little person, every time you get a wrong guess, you eliminate one of the programming languages from the world. So let's see, we've got a 5-letter word here. Oh, shoot. So E is not in the final letter. So HTML, it's been real. We've lost HTML. Let's try A. Oh no, CSS is gone. I, O. Ah, look at that. Okay, we've lost JavaScript, but we still have React on the line. Ooh, this is tough. Let's try an L. Let's see, is this the word floor? Nope. Oh no, we've lost React. Maybe blood? Ah, look, it is the word blood. So we are still left in this world with some usable languages, and we can see that we've won the game. This is going to be a super fun project to work on. You can click on the screenshots here to see the different designs that we have over in Figma. And I want to take this chance to re-emphasize the importance of trying to do all of the challenges on your own before watching me walk through the solutions. This is a critical part of your education, and it can be so tempting at even the first slight hiccup in trying to complete one of the challenges to then just click continue and watch me do it and think to yourself, oh yeah, I think I kind of understood that. I could have gotten that. That is very tempting, even for me, so don't fall into that trap. If you do feel like you get stuck, rather than just skipping the exercise and watching me do it, turn to the Scrimba community and ask for help. Or for more immediate feedback, start a conversation with ChatGPT and ask it to help clarify any questions that you have. You might even want to preface it with, don't write the answer for me, but help me understand this. Going through that process, although much more tedious than just watching someone else do it, is the way that you get better at this. All right, strap yourselves in for the battle of the welfare of our programming community. When you're just starting out building a project that's as exciting as this one, at least I think this is an exciting project, it can be so tempting to just jump immediately into the code and start building the project. However, it's a really good habit to get into to spend some time planning out your project. Even if you're not wireframing it and writing down a whole bunch of steps that you're going to perform, simply getting a high-level overview of the project and thinking through it ahead of time before diving deep into building it can really help set you on the right path. So before we code anything, I wanted to take some time to do a little bit of project planning together, and my hope is that it will help set a good direction for you as we go through the next series of challenges that we have. So I have a few questions that I came up with, and these are certainly not the only questions that might help you plan your project ahead of time, but one of the things that I like to ask myself, especially when we are given a design like we have here, remember you can click on these screenshots to go to the Figma design so you can inspect all the specific details of them. When we're given a design like this, something that I like to ask myself is, what are the main containers of elements that I'm going to need? As it turns out, this tends to be a great place to start scaffolding your app when you are coding it, so that you don't find yourself too deep down one rabbit hole without being able to show any progress on the other parts of the app. Another thing that you can think about is what values you're going to need to have in this app. Because we're working in a React app, you can think specifically what values need to be saved in state and what values might I be able to derive from the already existing state. Another thing that's important to keep in mind is the user that's using your app, and so you could ask yourself, how will the user interact with my app and what events do I need to be handling? So I've typed these questions out right here. Actually, I'm going to put a little bit of extra space between them because, just like a quiz, I want you to type in here the answers that you come up with on your own. There's no right or wrong answer for this. It's really just to get your mind working from a higher level view of the project to help guide your development from this point forward. I'm going to move the slides over to the screenshot of the game so you can refer to this, especially when you're answering questions 1 and 2, which might prove to be a bit of a help while you're answering these questions. So I'm going to put in a pause now, and I'll give you a chance to type out your answers to these. Okay, the first one, what are the main containers of elements I need in this app? Let's just use our winning state version here in the middle. We can see there's kind of a header up at the top. It's just some static information. We have this bar in the middle that seems to present some kind of game status. We have the you win or the game over, but we also saw when we were playing the game that it will give you messages along the way. So it's kind of a status section. Below that, we have a list of languages, which will be updating as you're playing the game. Next, we have the actual word that we're trying to guess with a blank spot for every letter of the word and the letters filled out that we have correctly guessed. Then we have a keyboard section, which is the main point of contact with our user. This is where they'll be clicking around to make their guesses. And finally, a new game button at the bottom, which will only show up at the end of the game. Identifying all of these sections gives us a great starting point with how we can start scaffolding or bootstrapping this project. Okay, let's see question number 2. What values will need to be saved in state versus what values can be derived from the state? I think the answer to this will become more apparent as we start writing our code, but it's still helpful for us to think about it ahead of time. Perhaps an even more enlightening question isn't what will be held in state and what will be derived from state, but simply what values do we need to know about? For example, we need to know if the game is over or not. Whether that's something that is saved in state or derived from state might become a little more obvious as we're writing the code, but it's good to know. We need to know if the game is over. We need to know if the user has won or lost. We need to keep track of how many wrong guesses the user has had, as well as what the randomly selected word by the game is, and which letters the user has already guessed. Knowing which letters the user has already guessed and the correct word will help us determine which keys on the keyboard should be green versus red versus yellow. The display of the new game button at the bottom will probably be determined by that value that we determined earlier, whether the game was over or not. And there might be a few other little hidden ones here and there as we go throughout the app. Now, you'll notice I'm not necessarily typing the answers down here. I think it's helpful to type the answers down, but for the sake of time, I'm just going to be speaking them out loud. Okay, we kind of touched on this already. How will the user interact with the app and what events do I need to handle? It seems like the main point of contact is our keyboard here. The user will be clicking on the keys, which should cause re-renders where it will determine if that was the right guess, wrong guess, change the keyboard, update our word, or kill off another programming language. So the keyboard is probably the main point of contact with our users. And lastly, a new game button, which of course will only show up when the game is over. Hopefully you can start to adopt a quick planning session like this into your own workflow, because I truly believe it's going to help you not only avoid pitfalls that you might not have seen otherwise, but to, in general, become a better architect of your code because you've given yourself the opportunity to plan things out ahead of time. All right, now let's take what we have just discovered through this project planning session, and now with a better overview, let's start building some pieces of this project. I've always felt like a great way to start making progress on an app is not to get too bogged down in getting all the functionality working right away, but instead to just get something on the page. So we're going to be taking little bites out of building this project by first just adding a little header section that includes the title of the game and a little description paragraph. The overarching goal for the next few challenges is to build out the main parts of the app, but we're just going to start with this little piece for now. One thing that can be helpful to note as you're working in CSS is that I have already made the body a flex container with everything justified to the center, which is why Game Goes Here is in the center. I've also changed the background color, the text color, the font family, and a few other things. Similar to the Tenzies app, as we're building out the main structure of the site, we will be spending a bit more time in CSS. And because this is a capstone project, I also expect you to write the CSS. I know that might not be everybody's favorite thing, but when you get a job as a React developer, they are going to expect that you know how to write CSS. Okay, go ahead and get started on this challenge. You might have noticed in the final version of the code that we saw that we had opted to kind of just put everything here inside of our hangman function. And actually, the name of this is a remnant from when I first started writing it. Let's call it assembly endgame. So we could spend a little extra effort by moving things out into other components, but at least for now, while I'm scaffolding, and potentially for the entire lifecycle of this app, I'm just going to be putting everything here inside of my assembly endgame component. So instead of game goes here, let's go ahead and create a header element. And because this is the title of the game, this is an appropriate place to add an H1. We'll say assembly endgame. And then let's add a description in a paragraph. And I am just going to paste in the text from the design. Let me start out by making this a little bit more narrow. And I think I'll wrap this just to save a little bit of horizontal space. Okay, we're going to have some design that we need to work on, which I think will be next. So I'll come over to my CSS and let's go ahead and select our header. Because we're just going to have one header, I don't know that I'm going to bother to give it a class name. I think it'll be enough for us to just select the element itself. The body is justifying this to the center, but the text still needs to be centered. So we can say text align to the center. And well, actually, that might be the only style on the header specifically. Let's go ahead and select our H1 now. And we will bump the font size down a little bit because the default styling is a little bit large. Let's go ahead and say 1.25 rems. The design also shows that it has a little bit less of a bold font weight, so we'll set that to 500. And yeah, it makes a tiny difference. And then we have to look a little bit closely, but in the design we can see that the color is slightly different from anything else. It's kind of a yellowish color. At least that's kind of how it looks on this background. Okay, let's go ahead and select the paragraph now, because that also has a different font size, which if we convert it from pixels in the design to rems, we get about 0.875 rem. I don't love how it's wrapping. It looks a little bit wide to me, so I'm actually going to include a max width. And let's try 350 pixels. Okay, that's wrapping a lot nicer, at least to me. And then we do have a different color, so we'll set that to the same color as the design. All right, this is a good start. Next, I think we'll just kind of work our way down the page. We'll start on this status section. We're still in these challenges where we're building out the main parts of our app, mostly focusing on having the static elements on the page. We'll worry about interactivity later. So your challenge this time is to build the status section, which comes right below the header. For now, because we're not worrying about having it be too dynamic, you can just hard code in a winning game state. Maybe that will boost your mood through the rest of this scaffolding process. So go ahead and get started on this challenge. As with most of these CSS challenges, there are certainly many different ways that you could do it. So don't feel like the way that I'm doing it is necessarily the best way or the correct way. It's probably just the way that makes the most sense to my brain. So below our header, I'm going to add a section. And while I'm here, I'll go ahead and give it a class name of, let's call it game-status. We'll get the content in here and then start worrying about the design for it. The style for the you win text inside of this status is not only a little bit larger, but the semantic meaning of it, I think, holds a little bit more weight to the status of the game. So I'm going to make it an H2. We've already used an H1 on this page, so we'll just move on to the next one, and we'll hard code in you win. And then below it, we'll just put a paragraph that says, well done. Awesome. Okay, I'll hit save so those elements will show up on the page. And yes, we have some styling to do. Let's go over to our CSS. We already created a game status, so I'll select game-status. And sometimes I like to give myself an indication as to what kind of element this is being attached to, so I'll do something like section.game-status. For now, we are going to hard code in the background color that's the green winning color. And because there's two elements in here, I could try to space them correctly and everything, but I think I'm just going to set this to a display of flex, use a flex direction, not flex basis, but a flex direction of column. I'll align the items to the center, and it looks like it's already justified to the center. I don't think I need to say justify content center. Yeah, but it doesn't appear to be doing anything. It looks like there's some default styling applied to the H1 and to the H2 and the paragraph. So let's select those individually. I'm just going to bring this line down and then access the H2. We'll set the font size to 1.25 rem. Oh, and it looks like in the design, the color is different. Oh, actually the color for both is different. So let's just do that in the parent here. We'll change the color to that kind of more yellowy color like our header up here. While we're at it, let's see what it looks like to get rid of our margin. And well, 0 is going to be not enough. So first, let's maybe do this to the paragraph as well. I'll set a margin of 0. Yeah, it's a bit squeezed. And I think if I make this something a little bit bigger, like 5 pixels, and we'll say 5 pixels. Oh yeah, that looks much better. Let's see, there's also a border radius, which we missed. So border radius of 4 pixels, it looks like from the design, just to round out the corners of the status. And then I want to separate it a little bit from this header. I can use either margin top and margin bottom, or I can combine them and use margin block, which is a helpful way to just provide margin to the top and bottom of an element. And okay, yeah, that separates it in a nice way. All right, this is looking good. On to the next challenge. In the next part of this challenge, we will add the list of languages with elements that are sometimes referred to as chips. They're just like little badge elements on the page. So that's the challenge this time. I want you to create those language chips. However, it's going to be a little bit more involved than that. I've provided to you a new file called languages.js. This is an array of objects, each object representing one of the languages that will get displayed on the page. Collecting them together in objects like this allows me to not only provide the name, but also whatever background color and regular color they should be using. I mostly didn't want that to be super tedious for you to have to do manually or to have to create 9 separate elements down here in your markup. Because this is a capstone project, I'm going to continue being pretty vague, but I did want to give you a hint for the layout, and that is for the container that you use around these elements. If you set it to a flexbox and make sure that it can wrap, it should make your job a lot easier. You might also need to apply a max width so that it doesn't just try to span the entire width of the page. For reference, I'm going to be using a max width of 350 pixels. Okay, that's all the hints I'm going to give you. Get started on this challenge. All right, let's create a new section. This section will act as the container for my language chips. And as such, let's go ahead and give it a class name of, well, let's just call it language chips, language-chips. Now, I'm not going to hard code anything here, but instead I'm going to import my list of languages from, let's see, languages.js export const. Okay, this is not default exported, which means I need to destructure it. And this is going to come from languages, and this needs to be a relative path. Let me just make sure this is working. I'm going to console log languages, and okay, good. They're coming into this file just fine. With that array of languages, I can map over them and create new elements on the page for each one of them. A common thing to do is to do that map operation directly here inside of your markup, although my personal preference has leaned towards creating a separate variable here in the body of my function before my return. So I'm going to create a new variable that I call language_els for language elements. No, let's call it language elements. And this is going to be an array from calling languages.map. We'll look at each language. And let's go ahead and return, we'll make these spans. They seem like they're maybe appropriate as a span. The text inside will be lang.name? Let's go check. Yeah, lang.name, and then we have background color and color. So we will use those in our styles. Actually, let me put this down in this section first and hit save just so we can see that this is working. Okay, that is terribly ugly, but we're on the right track. So inside of the span, I can provide an inline style, and so that's what I'm going to do. This needs to be an object, and actually, for the sake of saving my horizontal space, I think what I'll do is create a new variable, which means I can't do an implicit return anymore. Let me shuffle some things around here. We're going to return this span. I can get rid of this. And by doing that, I can now just create, I'll say styles is equal to an object where the background color is going to be lang.background color, and the text color or color is going to be lang.color. And then I can just pass in my styles object right here. The other way would have worked fine too. This feels better to me for some reason. Let's see if that made any difference. Okay, well, that's a good step in the right direction. I think in our CSS, we can style both the language chips as well as the individual language chip. So let me give this a class name, or rather give each one of these a class name. And I'm just going to call it chip for now. We'll hit save and then go over to our CSS. Oh, actually, let's fix this warning first, where we need to add a unique key prop. Our list of languages doesn't have an ID for each object, but the name is guaranteed to be unique because, well, we're not going to be adding to this list. So I'll just use the lang.name as the key, and I'm going to start putting these on their own lines. So let me add a key, which is equal to lang.name. Okay, good. Our warning is gone. Let's go over to our CSS. We have language chips that we need to style and chip that we need to style. So section dot language-chips. I had mentioned that we should change the display to flex and that we want it to wrap. So I can set the flex wrap to wrap. Okay, awesome. We need a little bit of space in there. They're really crammed in together. Let's give it a 5-pixel gap. We want things to be a little more centered. Let's justify the content to the center. And I had mentioned that I'm going to be adding a max width of 350 pixels. Okay, let's work on the individual chips, and I think that might finish us off. Those were spans with a class of chip. And let's see, in the design, it shows they have a border radius of 3 pixels and a little bit of padding around them. Looks like it's about 4.5 pixels. Wow, that's actually looking pretty great. Let me try resizing the browser here just to make sure that we're doing pretty good. And yeah, it's not a big deal if that wraps down, but we probably won't be getting too much smaller than this anyway. Nice work on completing that challenge. Let's move on to the next one. All right, let's display our word on the page. To do this, you will want to first create a current word in state, and for now, just for fun, we can initialize it as the word react. This represents the random word that the game will choose for us, but for now, we'll just hardcode it. Then, in order to display each of the letters, you'll map over the letters of the word, which means you'll need to turn it to an array first, because .map only works on arrays, and then display each one as a span element. Inside that span, just make sure you're capitalizing the letters. And then just generally style it to look like the design. Just a little hint in case it helps anybody, in order to get the little underline at the bottom of the box, you can simply use the border bottom property in your CSS. All right, go ahead and get started on this challenge. Let's create some new state just here at the top of our component. It will be for current word. And of course, set current word equals. And let's see, we're importing React. I think I'm going to import use state like this and call use state. And we'll just initialize it as the word React. I guess we could initialize it as capital letters, but this looks like it's screaming to me. So I'm just going to use React like that. All right, well, let's create another section where this can be held. I'll give it a class name of word. And I could do my map right here inside of my markup, but once again, I'm going to keep it consistent by doing it up here. Maybe let's call it letter elements. And I need an array to work with, but what I'm saving in state is a string. I can simply turn a string into an array by calling current word.split on every empty space, which if we console log letter elements, we can see gives me an array of all the letters in the word. And now that I have an array, I can map over it. All right, for each letter, I'm going to return a span, and we'll just put the letter in the span. We'll give it a class name. And actually, we can just select the span inside of Word. Yeah, let's do that. I'll hit save. Oh, we need to actually render this, so I'll take my letter elements. We'll put it here in the section. Okay, well, that's underwhelming, but let's go ahead and style it. Over in our CSS, we will select our section of Word. And I think I'll probably reach for Flexbox once again. We'll set the display to flex. We'll center it with justify content. I'm going to buy some room by putting a margin bottom on my language chips above there of, I think the design shows about 36 pixels. And let's put some effort now into the span. So I'm just going to select the child element of the span inside of my section. And each item will have a height of, let's see, the design shows 40 pixels. So we'll say 40, and then we'll also do a width of 40, a background color of this kind of dark color from the design. And then they are sitting in the upper left. I think for each span, I can also use a display of, let's try flex. I might have to change this. We'll justify the content to the center and align the items to the center. And oh, I'm just realizing that we're working with lowercase letters here. Not the end of the world, but I had asked to uppercase them, so I should probably do that. Here we'll say dot to uppercase. Okay, that is better. And of course we are getting our key prop error. Oh, and we're console logging stuff still. Let me clean something up here. let's see, right here, we're console logging the letter elements. Let's get rid of that and we'll hit refresh. Okay, we're still getting the key prop issue. So when we're mapping over this, I guess we need to decide what unique property we're going to use. Now, this isn't something I normally would advise doing, but because we're working with something that isn't guaranteed to have unique elements, I might be working with a word that has multiples of the same letter. I can't just use my letter as my key. But I do know that I'm not going to be removing any letters from this list or rearranging them or anything. I mean, in the game, I might be hiding them, but the word itself is not going to be rearranging the letters. And because of that, I can actually access another property inside of my callback function for .map of the index of each item that it's mapping over. And for now, this is going to work just fine as a key because, again, I won't be rearranging anything and it will never get confused by React. Okay, that suppressed that warning for us. Looks like we're almost there. Let's go back to our CSS. I think we can bump up our font size. This would be the equivalent of 1.125 rem. Okay, let's add that border bottom of 1 pixel solid, and then it's this color from the design. And in the design, it shows a little bit of space between these. Let's add a gap of 2 pixels. And oh, not to the word, but to the word list here. All right, wow, that is looking awesome. Again, I know we're doing a lot of CSS here. We just have one more major element that will take a bit of CSS, and that is our keyboard. And after that, we'll finally be able to start jumping into the functionality of this app. Arguably, the most important part of this app is the keyboard. It's the main thing that our users are going to be interacting with. And it's your challenge to get it up on the page. I've created a static variable that just has all of the letters in the alphabet that you can use to map over the letters and display the letters in the keyboard. Make sure that you make each letter in the keyboard an actual button element because, well, semantically, that's correct, and it also will come with a bunch of free accessibility benefits as well. Go ahead and get started on this challenge. All right, let's come down and I'm going to create yet another section. We'll open that up. I'm going to give it a class name of, let's say, keyboard, and we'll come back to the styling in a minute. Kind of like we're doing up here, we'll render, what should we call it? Maybe keyboard elements? We haven't created that variable yet, so let's go ahead and do so right here. Keyboard elements is equal to the alphabet.split. The only reason we have to split it is because I wrote it up there as a string just so I didn't have to type as many characters trying to put each letter as its own string in an array. Okay, so this gives us an array, and then we can map over that array, and for each letter in that array, we will return a button element. It's going to have the letter inside, and actually, I forgot to mention this, but I wanted to uppercase it, so that's what we'll do. We're mapping, so we need to make sure that we include a key, and because we are only rendering one button for each letter of the alphabet, I can use that letter as a unique key. We're not worrying about the functionality for it quite yet, so I don't know. Let's see where it is. So we'll hit save, and oh, whoops, I did that wrong. That's supposed to be the actual variable of the letter. That's why I got my key warning. Okay, there we go. You could have chosen either Flexbox or Grid to style it. Honestly, because of the design, Grid seems to make more sense, but because of my stronger familiarity with Flexbox, I'm actually going to lean on Flexbox to handle this one. So let me access the section with the class of keyboard. We'll give it a display of flex. We need to make sure that it can wrap, so I'll say flex wrap wrap. We'll give a gap of 8 pixels. And let me space it away from the word a little bit, maybe right up here. We'll give a margin bottom of like 20 pixels. Yeah, it looks better. We'll justify the content to the center. And I believe it's going to, yeah, it's just going to keep spreading out. So again, I'll give this a max width of, I think the design shows it's around 450 pixels. Now things aren't lining up super well, but I suspect that has to do with our actual keys. So let's access section.keyboard and then the spans inside. No, the buttons inside. All right, the design shows that it is 35 pixels high and wide. Oh yeah, look at that. That lines up much nicer. I'm going to copy the background color from the design. Let's change the default border for these buttons to a 1 pixel solid, and then I'll paste in this color from the design as well. I usually like to make my buttons have a cursor of pointer. And oh, we need a little bit of a border radius as well. I think it shows that it's 3 pixels. All right, I don't know what you think, but that seems like it is working and looking pretty good to me. Now, the last piece of our app is to have this new game button at the bottom. But because I love you guys and you've done such a great job on the challenges so far, I have a little surprise. I can snap my magic fingers, and just like that, we now have a new game button in our app. Yay! I figured this was an easy enough element, we didn't really need a whole separate challenge for it. We're in our second capstone here. You don't need a challenge on how to add a single button. Okay, well, it sure is looking good, but of course it's not doing anything. So let's jump into the next challenge where we will start adding some functionality to this. All right, so we've added the keyboard. Let's start working on making the keyboard actually work. Of course, the user is going to click these letters in order to give their guesses as to what should be in the word. Right now we're displaying the word. It's going to be blank letters, of course. So our overall goal for the next few challenges is to allow the user to start guessing the letters by clicking the buttons. The specific challenge for this scrim is to be announced, but first I want you to think what's going to be the best way that we can store the user's guessed letters. I'm going to put in a pause here and give you a chance to think through that. Because we need to remember the user's guessed letters across every render of our component, and we know that when the user guesses a letter, we want to update the UI in a few different ways, right? We need to display the letter here. If it is a correct letter, we need to cross out one of the languages. If it's a wrong letter, we need to change the keyboard key color if it's right or wrong to either green or red. So because of all those things, we want to make sure that we save the user's guessed letters in state. So let me type out what your challenge will be. Your challenge is to create a new array in state to hold the user's guessed letters. And when the user chooses a letter or clicks one of these buttons, you need to add that letter to this state array. For now, we're not going to worry whether it was a right or wrong guess. There's a few other ramifications with that, so we're just going to focus on adding it to the state array. And you'll probably want to console log this array just here near the top of the component so that you can make sure that it's working correctly. Go ahead and get started on this challenge. Okay, we'll create some new state. Maybe we'll call it guest letters and set guest letters is equal to use state, and we'll initialize it with an empty array. Let's go ahead and console log our guest letters. As a reminder, this console log is going to run every time our component gets re-rendered, and because we're about to make it so that clicking the button will set state, that will re-render it, and that will run our console log right here. Okay, maybe right below the alphabet here, I'll create a click handler. We'll call it maybe add guessed letter. We are going to need to know what letter was guessed, so we'll assume that we can pull that in as a parameter to the function. To update our state, of course, we will call set guessed letters. We do need to know what the previous letters were, so we'll access the previous letters in a callback function. And as a first iteration of this function, let's just say we're going to return a new array that has all of the previous letters and then adds the new letter at the end. Some of you might already notice what kind of issue we might face with this, but we will fix that in a second. Let's take add guessed letter, and where are our buttons? Right here's our keyboard buttons. And so I will add, maybe right here, I'll add an on click that runs add guessed letter. But I need to do a little bit more than this because remember, when I have an event listener like onClick, if I just pass a function, I don't get to choose what parameter it receives. It's going to receive an event object from JavaScript. So what I can do is simply wrap this in its own anonymous inline function, and then the only thing that function is going to perform is calling add guessed letter, at which point I can pass in the letter while we're mapping over them to that function. This is getting a bit wide. Let me clean this up a little bit. Okay, let's hit save and open our console. A, B, C, D, E, F, G. Awesome. If you haven't yet discovered what bug I introduced in the way that I wrote my add guest letter function here, I'm going to refresh this page and give you a chance to see if you can figure it out. So I'll put in a pause here, see if you can figure out what kind of bug we have currently. If the user keeps guessing the same letter a bunch of times, we are going to be duplicating the guessed letters in our array. And that's not what we want to do. We want to make sure that we are only including letter into this array if it isn't already present. There's a few different ways that we can do this, and just for fun, I'll show you 2 different ways that you could choose. The first thing we could do is, let me put this on a separate line. Actually, let me just get rid of this. We're going to be doing it from scratch here. One way I can ensure that I'm not duplicating the letters here is I can check if the previous letters already includes the letter that I'm trying to add. And I can use a ternary that says if that returns true, in other words, the letter that I'm trying to add already exists in the previous letters, then I can just return the previous letters. I don't need to make any changes to it. But otherwise, I can do what we were doing before, where we just spread in the previous letters and then add the new letter to the end here. Let me put these on their own lines as well. Let me hit save and just make sure this is working. If I click A, I get A added. If I click A again, okay, it's not adding it. Perfect. Let's do B and C and then try to do A again. It looks like it's logging it to the console, but at least it's not adding the previously guessed letters to the array and duplicating them. Again, just for fun, I think it can be a good learning experience to see another way that we can do this, perhaps using an API in JavaScript that you're not yet familiar with. I'm going to get rid of what we had, and let me fix my brackets here. Open up the body of this, and what we can do is create something called a set in JavaScript. A set is very similar to an array in JavaScript, except it doesn't allow for duplicates. It's built into JavaScript to not allow duplicates. And so what I could do is create a new variable, let's call it maybe letters set, and that's going to equal a new set, and we can pass in the array of previous letters to pre-populate this set. Then I can say letterset.add. Sets in JavaScript have a method called add, and you can add the new letter to the set, which will automatically remove duplicates from the set. Then I can turn the set back into an array and return it by using return array.from my letter set. Let's go ahead and see how this is working. I can click A. Yep, I'm clicking A a bunch of times. This does have an interesting side effect where it is re-rendering our component, even though we're not changing the state of this variable. So that's kind of interesting, but it is working. And oh, we're probably not seeing those lower ones. So I can click A, B, 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 C, 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 and the array just has A, B, and C in it. Well, I haven't taken the time to figure out why it is re-rendering the component every time I click it, whereas what we had before is not. And so I think I'm actually just going to back up to the other version right here, and we'll just leave it at this. Either solution is completely fine and valid. Okay, now that we have a way to store in state the letters that the user has guessed, we have the ability to start working on some of the other user interface pieces of the app where the game can give feedback to the user. So that's what we'll dive into next. All right, folks, this is one of those challenges that's going to require you to think critically. I'm being pretty vague in all the steps that will need to take place in order to complete this challenge. And as a bonus, you are going to get a chance to read about and use a fairly popular third-party React package. So first, let's talk about the challenge. I want you to update the keyboard keys to display whether the selected letter that the user just clicked is right or wrong. As you can see from the design, if the letter is a correct letter that's in the word, then it turns green. If it's wrong, then it turns red. For testing purposes, we're still keeping the current word as React and displaying it here. We're going to get to obscuring that and choosing a random word later, but this will really help with testing. Of course, if you hit R, E, A, C, or T, then the letters should turn green, and if you choose anything else, they should turn red. As a bonus, I am recommending that you use this CLSX package. It's going to require you to go learn about it, but as you can see, it receives about 21 million weekly downloads, so it is a pretty popular package, and its whole purpose is to give you a chance to construct the class name string. That's the string that you are passing into your elements like this right here. Class name, we have hard-coded it to be chip. Or in the case of the button, which we are going to be styling, we are not passing in any class names, and CLSX gives you a chance to construct those class names conditionally. So if you want to use CLSX, you're welcome to do so. Click on the screenshot here to go to NPM and read all about it. There's a chance that the documentation may prove a little bit confusing. If you find that's true, then don't be afraid to turn to Google or the AI assistant of your choice to ask how this package is used. So try to psych yourself up for this awesome challenge, and I'll turn it over to you to start working on it. When I first was building this app, I thought to myself, I wonder if I should save in state an array of all the correct letters and another array of all the incorrect letters. But then I realized that we can easily derive that value by simply looking at the array of guessed letters and by looking at the current word. As we are mapping over the alphabet and displaying the buttons for each letter of the alphabet, we can take the opportunity to check if the current letter that we're looking at is in the array of guessed letters, and if it is, then we can check to see if it's correct or not by seeing if that letter is also in the current word. If those two conditions are true, in other words, it's been guessed and it's in the current word, we can change it to the green background. And if it's in the guessed letters but it's not in the current word, then we can change it to the red background. No new state necessary at all. I can simply derive those values based on the state that we already have. So let's come down to our keyboard elements here. And I'm going to need to include some additional logic before I return this button. So I'm going to open up a set of curly braces and move my button inside just so I have some ability to write some additional logic here. I'll go ahead and put this in a parentheses. Wow, I have some serious formatting issues to figure out right here. Okay, but now that I'm doing an explicit return, I can start writing some additional logic up here. So let's think, what are some of the values that I need to know? Well, I need to know if the letter has been already guessed. Remember, I'm mapping over the alphabet, and this map operation is going to happen every time our component re-renders, which means I know that I can have an updated version of our currently guessed letters and the current word. So if I want to know if the letter has been guessed, I can simply check inside of the guessed letters to see if it includes the current letter that we're mapping over. Okay, well now let's check to see if the guessed letter is correct. Well, first of all, it's important that the letter has been guessed, otherwise it's neither correct or incorrect. So if it is guessed and the current word includes this letter, then yes, this is a correct letter guess. And it wouldn't be enough to have an is wrong variable that simply says it's not is correct, because every letter would be considered wrong because we're not comparing it to make sure that it's been guessed. So we would simply say const is wrong is, and I'm just going to take this logic and reverse the fact that it's included in the current word. Okay, how is this helpful? Well, at this point, I could now add a class name to my button and try to do a crazy nested ternary that says, first, let's check to see if it's guessed, and then if it is, let's check to see if it's correct, and if it isn't, let's check to see if it's wrong, and apply certain class names accordingly. But this is where the CLSX package comes into play. What CLSX allows me to do is create an object where the keys are the names of the classes that I might want to apply, and the values of those keys is a Boolean as to whether or not that class name should be applied. This will be much easier to just show. So let me go ahead and create a new variable called class name, and this will be the string that gets returned by calling the CLSX package, or function rather. There's a bunch of different ways to use CLSX, as I'm sure you discovered from the documentation, but the most common way that I find myself using it is to provide an object. And as I mentioned, the keys of this object will be a potential class name that will end up on the button in the end. So, for example, I might have a class name called correct, and I only want the correct class to be applied if isCorrect is true. And I could do another one for wrong or incorrect. Let's call it wrong, and say this is if is wrong is true. I haven't created these class names yet, but let's finish up our work here. First of all, I need to apply this class name that results from calling CLSX, and I don't believe I've imported CLSX yet. So let's go ahead and do that before that becomes a problem. Import CLSX from CLSX is a pretty hard thing to say, actually, now that I'm saying it so many times. While we're still here, let me go ahead and console log class name. We'll get a better idea of what's going on here. Well, this console actually doesn't show anything, but the little pop-up down below shows that it was an empty string. Let me see what happens if I click A. Oh, whoops, we do have an error here. Current word.include is not a function. Yes, this needs to be includes. Sorry for anyone who was shouting at their screen because that was a mistake. Okay, let's try this again. We'll click A. Okay, look, it console logged correct. If we put B, it's going to console log both correct and wrong. And that's because what it's doing here, as it's looping through the entire keyboard, it's looking at each letter and it saw that A was guessed and it is in the final word or the current word, which is react. So we have an A there. Is correct became true. It applied the class name of correct and then it just console logged that class name for that specific letter, which was correct. Then it continued through its map and it got to the letter B. It said, yes, this is in the list of guessed letters. And so it is guessed, but it is not in the current word. So is wrong is true, which means that wrong is going to be applied and it console logged wrong. And then I think behind the scenes, there's actually a bunch of empty strings that are happening because every other letter in here is not guessed. Okay, let me close the console. I have some styles that I just have copied over. It just has the background colors from the design. So let's see, here's our keyboard, and we'll just put these right there. Okay, button.correct and button.wrong. And I would have thought that would have applied. Let's go ahead and hit save. Let's try A. And oh, you know what is happening? We have a specificity battle going on. Up above, I am being more specific about this button than this button. So I guess let's just add the same level of specificity. Well, actually increasing the specificity. And okay, there we go. We get our letter A being colored as green because it's in the final answer. Let's go ahead and click B, and awesome. So let's go back up to our challenge. And sure enough, we were able to update the keyboard when a letter is right or wrong. This should work all the way through. R should be in there. Let's see, T should be in there, and we've gotten all the letters, so everything else should be red. Feel free to continue playing around with CLSX. We are going to be using this in a couple different places in this project, mostly to help us avoid any crazy nested ternaries or having to write a bunch of conditional logic just to determine our class names. I guess another thing to note about this package is that although we are using it in a way where these are mutually exclusive classes, it doesn't have to be that way. You can provide an object that has a lot of different class names, and it will just apply all of them where the value at that key ends up being a truthy value. All right, we're making great progress. Let's keep it going. All right, there's really no hints that I'm giving you this time at all. I'm just asking you to add the next feature to our app. So your challenge is to only display the correctly guessed letters in the word. Right now we're displaying the entire word, which of course defeats the purpose of a game like this. So now that we have some UI feedback as to whether the letter that they guessed on the keyboard is correct or not, if the letter is correct, then we want to display it in the final word, but otherwise we just want it to display nothing, I guess an empty string. I'm going to let you find where in the code you would need to make that change. And that's it. I'll hand it over to you now to work on this challenge. Well, naturally, I think the first place we want to look is where we are displaying these letters. And so if we come down to the letter elements, this is where we are looking at the current word. We're splitting it so it's an array. We're mapping it. And then for every letter in that array of letters, so R, E, A, C, and T, we're creating a span. And inside that span, we are just automatically putting in the letter. So this is where our logic is going to live. Instead of always putting the letter in, we could put in a ternary here that says if the guessed letters, remember the array that we are keeping track of as the user is clicking the buttons, if the guessed letters includes the current letter that we're mapping over in the current word, that means that the user has guessed this letter and it was correct, because at this point we are only mapping over the letters in the actual word. And so I can use this ternary that says if the guessed letters array includes the letter that we're looking at, and I'm actually going to pop this onto its own line here, then I want to display the uppercase version of that letter, but otherwise I'll just put in an empty string. So when I hit save, all of the letters should disappear. Perfect. Oh, it looks like I still have a console log hanging out for this class name. Let's get rid of that. So the letters disappear, and then let's start guessing the letters. We know that it's React, so R, E, A, C, and let's do a non-letter like W, and okay, perfect, nothing else updated, and we'll do T. Awesome. Although the final code ended up being pretty straightforward, hopefully this was a good challenge because Remember, I only gave you the feature that we wanted to add, and it was up to you to figure out how to do that. If you were able to do that, that is a great sign that you are following along, you're understanding this code, and ultimately, hopefully, you're not getting stuck in tutorial hell by just watching me do all of this without actually getting your hands on the keyboard and practicing. We're making great progress. Let's keep it going. We're on to the next goal. So far, there's basically no consequences to getting wrong letters, and so we need to add a little bit of tension to the game by adding in the mechanism that will count the number of incorrect guesses and actually have consequences that lead the user to potentially losing the game. In this game, we only have 8 wrong guesses that we're allowed to get before assembly is the only language that we're left with in the world. And so we need to be able to count how many wrong guesses the user has had. We talked earlier about how we could have chosen to track in state an array of correct letters and then another piece of state for the wrong letters. And honestly, that could have worked just fine. However, the way that we currently have this set up, where we have the current word and the array of guessed letters, both of which are being held in state, we can actually figure out how many wrong guesses the user has had based on just these 2 values. So your challenge is to do exactly that. I want you to derive a variable which you can call wrong guess count for the number of incorrect guesses by using these other state values, current word and guessed letters, that we're already holding in this component. We're starting to add a bunch of extra values here, either for state or this static value, or we're about to create a derived value. So I'm actually going to create a little bit of separation with some comments. I'll say that these are the state values. Let's say this is a static value. And we'll just say values in case we have to put something else there. And right here, we will add a section for derived values. For now, once you have created this variable, just to test it, we'll say that you can just console log the variable, or let's say the wrong guess count. We'll make better use for it in the upcoming challenges. All right, the time is yours. Go ahead and get started on this challenge. Well, we have an array of all of the guessed letters, both correct and incorrect ones. So if we could filter out the correct letters from this guessed letters array, all that would be left is the incorrect letters, and then we could simply take the length of that array to get the exact count for the number of wrong guesses the user has had. This certainly is not the only way to do it, but it is the way that I will be proceeding. So we'll say const wrong guess count. And actually, just for now, so that I don't have to try and chain too many things together, I'm going to maybe have a wrong guesses array, and we'll just take care of this in 2 steps. I will probably end up combining them once we understand what's going on here. Okay, so let's look through the guessed letters array, and we're going to create a new array by filtering out the correct letters. And so my filter is going to look at every letter in the guessed letters array. And we only want to include in the resulting array, this wrong guesses array, the letters that are not in the current word. So I can say current word dot includes, and I'll go ahead and put my negative there because I want to make sure that the current word does not include the current letter that we're looking at from the guessed letters array. Let's do a little bit of an intermediary step. We'll console log the wrong guesses array. Okay, starts out as an empty array as we'd expect. If I add A, okay, we're still an empty array because that was a correct letter. Let's go B. Okay, look at that. We've got a B in there, D, F, perfect. Just for good measure, let's put in a correct letter. Okay, we're console logging the array again, but it does not, of course, include the correct letter. Great, well then obviously the only last thing we need to do is take the length of the wrong guesses array, and that's going to give us our wrong guess count. At this point, instead of creating a separate variable, I'm just going to have the wrong guess count like this and chain on a dot length at the end of everything else that we have. Let's just go ahead and make sure, oh, whoops, I put this in the wrong place. This is where I put the dot length, and I want to console log the wrong guess count. Okay, let's try it out. 0. A is correct, so we're still at 0. E is correct, still at 0. D, okay, we're at 1, 2, 3, 4, and 5. Cool. This wrong guess count is going to be pretty crucial for us to be able to do a couple of the other things involved in adding this incorrect guesses mechanism to the game, like starting to cross off different programming languages, or knowing if the game has been lost. That's also going to help us fix our status section up here, which currently is just hard-coded to you win. And so this was a pretty important feature that we just added. And something that I think is kind of nice is that we were able to just derive it from the state that we're already maintaining. Generally speaking, if you don't need something to be in state, it's usually better for it not to be in state. Let me go ahead and clean up some of these extra spaces here. And awesome, great job on this challenge. On to the next one. Now that we have access to the number of incorrect guesses from the user, one of the first things we can do is to mark off the languages that have been lost based on how many incorrect guesses there have been. To me, the CSS for adding this little gray overlay and the skull felt a little bit outside the scope of the course, and so I just went ahead and added these rules here. It's just a pseudo element where if you add the lost class name to our language chip, it's the span with the chip class, then it will gray it out with an overlay that's opacity of 70%, and it has this little skull emoji and everything else here. Feel free to look through these CSS rules if you want, but as I said, it just felt a little bit like a distraction to worry too much about this. The only thing you really need to know is written up here in the challenge text. When you're mapping over the languages, you should determine how many of those languages have been lost and then add the lost class if it is a language that's been lost. I give a hint here where you can combine the wrong guessed count that we figured out in the last scrim right here and combine it with the current index of the item in the array as you're mapping over the languages array. You're welcome to use CLSX if you want. If you do decide to use CLSX, you'll need to refer back to the documentation on how you can always include a class name, because right now we are including this hard-coded chip class name and we want to make sure we don't lose that. This one, however, is a relatively easy one to do manually, just right here inside of this class name prop if you'd like. All right, time to get your hands on the keyboard. All right, so let's come down to where we are mapping over our language elements. And let's try to reason through how we can determine if the current language that we're looking at while we're mapping over them is a lost language. Well, if we can get access to the index of the current item in the array, since our array will always be in this same order that we see here, we can know that if we have a wrong guess count of 1, then any index that's less than 1, or in other words, any index that's less than the number of wrong guesses, should be considered a lost language and needs to get the lost class name added to it. Inside the callback function of my .map, I can add a second parameter called index, which gives me access to the current index of whichever item we're mapping over. And with that current index, I can create a new variable that says something like is language lost, and set that equal to the Boolean that results from saying the index is less than the wrong guess count. So if our wrong guess count is 0, then even the item at the 0 index is not going to be considered lost because 0 is not less than 0. If our wrong guess count is 1, then this will evaluate to true for the very first item, and we'll mark it as lost. If the wrong guess count is 2, again, this will evaluate to true for the items with the index of both 0 and 1, and so forth. With this isLanguageLost variable, I now can update my class name to include the lost class name if that's true. And I'll just show this in two different ways. I can do this manually by updating my class name here to use a template string and simply say isLanguageLost and use a ternary. And if it is lost, then we'll add the lost keyword. Otherwise, we'll just maybe use an empty string so we don't add any additional classes. And let's try this out. We'll hit save, we'll choose a wrong letter, and awesome. Well, not awesome. We lost HTML. Let's do a correct letter or maybe a few correct letters and then another wrong one. Oh no, okay, bye CSS. Okay, look at this. We are doing this correctly. Okay, well, since we do have the CLSX package, I guess it doesn't hurt to use it. So right here, I'm going to create a class name variable and I'll give CLSX a call. We want to make sure that unconditionally we always include the chip class. And so if one of the parameters that I pass to this function is just a string, then it will just always include that in the final resulting class name. I also don't have to use an object like we did with the keyboard letters. Instead, I can just pass in a ternary here that says is language lost. If so, then include the string lost. Otherwise, well, actually, you know what? I could even do the short circuit double ampersand method, and this should work just fine too. In CLSX, if this evaluates to false, then it just will ignore this parameter to the function anyway. Then I can come down here and just update all this with the class name that we determined above. Let's hit save, and we should get the same results. We're getting closer and closer to the end. Great job on this challenge. And since I don't think I've said it recently, take some time to look through our code again. If any of this has been confusing for you, it's time to put in the effort to become familiar with this code before just plowing ahead. There's absolutely nothing wrong with doing that. In fact, just plowing ahead will put you in a worse spot in the end. Once you're ready, we'll keep moving forward. Currently, we are rendering our new game button even at the beginning of the game. Your challenge is to create a new derived variable called IsGameOver, which evaluates to true if the user has guessed incorrectly 8 times. 8 times because we have 9 items in our languages array, but we want to leave assembly as the only remaining language at the end. That said, I do want you to consider how we might make this value, or this IsGameOver value, a bit more dynamic if we were to ever add or remove languages from the languages array over here in this languages.js file. Once you've completed challenge number 1, your second challenge is then to conditionally render this new game button only if the game is over. And at this point, it doesn't matter if they've won or lost, it's just if the game is over. For this first part, try to think critically as to what conditions in which the game should be considered over. And in this case, I don't mean game over like in the old Mario game over where you lost. It really just means game over whether you won or lost. All right, your turn to take the reins and work on this challenge. I didn't type this down, but I did mention it as I was speaking. But this IsGameOver value is something that we can derive based on the existing state. And because we know that the game should be considered over whether the game was won or lost, maybe the first thing we should do is try to derive some state about whether the game is lost, and then we could say, well, the game is over if either the game is won or the game is lost. So let's go ahead and first create IsGame1. And again, you may have chosen a completely different way to approach this. That's okay. I didn't say anything in the challenges about creating these extra variables. I'm just going to use them to separate my logic out a little bit more. Okay, well, how can I know if the game is won? Let's think about this one. Well, I've got my current word. This, of course, has all the correct letters in it. What if I were to check to see if every single one of the letters in our current word was also in our array of guessed letters? That should mean that the user has guessed every one of the letters in the current word, which should indicate that the game has been won. I could do a for loop to loop over every letter in the current word. I could use a .map, but there is a built-in method called .every, which allows me to pass in a function that should return a Boolean for every item in the array on which I'm calling .every. The callback function returns true, then the entire expression evaluates to true. That's going to make a lot more sense if we actually see it written down. So first I need to take my current word, which is a string, and turn it into an array so that I can even call the .every method on it. So we'll say current word .split, and that will give me the array of letters in the current word on which I can call .every. And we'll look at each individual letter, and if the guessed letters array includes this letter, this will evaluate to true. And if every single letter that we map over in this current word returns true, as in every one of those letters is included in the guessed letters array, then .every will return true, and this entire expression will return true. And so IsGame1 will be the Boolean value true. Okay, cool. I think that should work just fine. Well, maybe let's go ahead and console log it. So we'll console log IsGame1. We'll hit save and then just type out the correct answer. So false, that's good. We haven't yet won the game. REAC, that's a bunch of falses, and then T, and we evaluate to true. Perfect. Let's close the console, get rid of our console log. Now let's work on IsGameLost. This one's a little different. Intuitively, it might seem that we should just say it's the opposite of IsGame1, but the state of the game isn't either won or lost. There's also a currently in play state of the game. Instead, we'll need separate logic to determine if the game has ended and is lost. Well, we know that the game is lost if the user has a wrong guess count that is equal to 8, or I guess greater than or equal to 8, just to cover our bases. And actually, let's type it out that way first. We'll say wrong guess count is greater than or equal to 8. But now, as I mentioned in the challenge text, it would probably be helpful for us to consider how we can make this more dynamic if the length of the array were ever to change. So maybe instead of 8 hard-coded, we'll just say languages dot length -1, because again, we need to leave assembly here so that at least if all the other programming languages disappear, we can still program something. Well, somebody can program something. I certainly couldn't. Okay, so that finally leads us to the IsGameOver variable. The game is over if either the game is won or the game is lost. So now that we've put that work in, we should be able to easily say IsGameOver is equal to IsGameWon or IsGameLost. This is kind of just an intermediary convenience variable. Anywhere that we are relying on it, we could have theoretically just said IsGameWon or IsGameLost, but this way is a little bit fewer characters. All right, so that was challenge number 1. Number 2, we need to conditionally render the new game button only if the game is over. So we'll come all the way down to our button right here, add some curly braces, and we'll go ahead and say, is the game over? And if that evaluates to true, then we will render this button. Okay, let's test it out. We'll hit save, and let's see, should we win or lose first? Let's go ahead and win first, REACT. Okay, cool. Our new game button has shown up. Let's refresh this and just do a bunch of lost letters here. Oh, I guess D is in there. Okay, one more and we should be up. Not going to do R. Let's do Q. All right, the new game button showed up there too. Perfect. With our new derived values, we have a new improvement that we can make to our app. So that's what we'll jump onto next. Now that we know whether the game is over and whether the person has won or lost, we can come back down to this game status section and update it so that it's not a hard-coded you win, but instead we'll only display this you win, well done message if, of course, the user has won the game. Or alternatively, we'll display this game over, you better start learning assembly if the user has lost the game. There's actually a third status that we're going to include here, which is a sort of farewell message to each one of these programming languages whenever the user gets a wrong guess, but we'll be worrying about that in a little bit. So for now, your challenge is written up here. I want you to conditionally render the won or lost statuses from the design, both in the text and the styles, based on the new derived variables that we created, is game won, is game lost, or is game over. As a quick note, we want to make sure that we're always rendering the surrounding section. So you can see in the design here, even when there is no message being displayed, we want that space to be open. And if we were to remove that section from the DOM with conditional rendering, then I think everything else would kind of bump up. And then when a message popped up, everything would bump back down. We just want to leave that like an open slot. All right, the time is yours. Get started on this challenge. Let's come down to this section, and we're going to be dealing with this section right here. And as I mentioned, we don't want to conditionally render this whole section because things would start to jump around on the page. Instead, we can conditionally render what's inside that section. So we will open this space up a little bit. One point of trouble that you may have run into is that we get an error if we surround two of these elements in curly braces like this. Just like how components need to return a single parent element, if we're going to be evaluating an expression that has some JSX inside, it needs to be surrounded with a single parent element. We could use something like a div, or because we don't necessarily want to add any additional elements to the page, we can just put in a fragment, just like this. Now, there's a lot of different ways that we could handle the conditional rendering here. And there's certainly not one correct way, just like in most of the stuff that we do when we're building these apps. So the different approaches that I'll show you now are just different options that you might choose. On the top level, we can think of it as having two different states. One where the game is not yet over and we want to display either a blank space, or if we go into this design, the little farewell message while we're in the middle of playing the game when the user chooses a wrong letter. Or the other state is that the game is over, and then it kind of branches again from there. Either they've won or they've lost. Currently, we are only really dealing with this second scenario where the game is over, and we can use a ternary to help us determine on the top level which of those two major states, whether the game is over or the game is not yet over, is true. So let's say if the game is over, then we will render this section. And for now, I'm just going to put an else in here that maybe just says null. Let me format this because my spacing is looking a little funny. At this point, we could decide whether we want to nest another ternary inside here to check if the game is won. And if the game is won, we render this one that says you win, and otherwise we render the one that says that you lost, or game over. Alternatively, we could just change the text because we want the H2 and the paragraph to stay there whether they've won or lost. But for some reason, I think I would prefer to nest a ternary here. In this case, it wouldn't be terribly confusing. I think I'd be able to read it kind of like an if-else statement, which is a little bit of foreshadowing as to the next way we're going to see to do this. So rather than putting a ternary here to determine the text and then another ternary here to determine this text as well, let's go ahead and just give this a shot. We'll say if the game is won, and we're just nesting a ternary here, we'll move this fragment with the H2 and paragraph inside. And if the game is not won, in this instance, we can know that the game is lost because we're not reaching this code unless the game is over. And then there's only two options from then. The game is won or the game is not won, which means the game is lost. So maybe then we'll just copy this and we'll indent it and then we'll change our text. It says game over. And then this one says, you lose, better start learning assembly. And I just copied that from the design. This is something we'll be coming back to later, but I guess this isn't so terrible. If we have our indentation correct, then we can kind of read this like an if-else statement. Before we refactor anything here, let's go ahead and get our styles working because our styles are still going to make it look like they have won, even if they've lost. Let me just guess a bunch of wrong letters here. Okay, so it says game over, you lose, which is great. That's a good first step, but the green box sure makes it look like we won the game. Just like how there's different ways that we could have done this conditional rendering, there's a few different ways that we could handle changing the styles as well. Because we're kind of on a kick using CLSX here, I think I'm going to use CLSX. So above my return, just right here, I'm going to create a new variable called GameStatusClass. And I'll set that equal to CLSX, or a call to that function CLSX. We have a class name that's already being used here of GameStatus. So let me copy this and put that as my first argument, which just means that I want you to always include the GameStatus class. And I guess I'll go ahead and set this equal to the GameStatus class. This is the string that's being returned from CLSX. And then I can provide maybe another object where I have different properties, like a won class that is determined based on a condition and a lost class that is based on another condition. Well, we have variables that I think help us know when we're won or lost. So I will apply the won class if is won or is game won is true, and I'll apply the lost class if is game lost is true. And we'll keep a close eye on these to make sure that this logic is correct. Let's go ahead and refresh this app. We haven't changed it since we added our little nested ternary in there. And okay, because the game is neither won nor lost, we have a blank message there. But the space is still being taken up, so that's good. The green box is not good. So let's go over to our CSS and add some rules for won and lost. So let's go over to the CSS, and here's our section with the game status. And I think right here, I'm going to add section.gamestatus.won, and I'll do the same thing for .lost. Both of these will just be changing the background color, and the winning color is this one. Actually, I guess I can just take this line out of there and put it right here. And the losing color from the design is this one right here. All right, let's go intentionally lose the game to see if that's working. Actually, let's win the game first. We owe ourselves that. Okay, React. Awesome. Okay, the space got taken up. It has the green background. It's got the new message. Perfect. Let's refresh and we'll intentionally lose the game. Okay, perfect. As you can tell, a successful completion of this challenge did require a bit more than what I had led on in the beginning. I just gave you the feature and expected that you would be able to think critically and do some of these tasks by yourself. This was a hard challenge. So if you didn't quite complete it, then like I've said before, don't feel bad. This is all part of the learning process. If you were able to complete it, then do your little happy dance because that's pretty impressive. I had mentioned that we might look at a different way to do this conditional rendering, and so I think in the next lesson, I'm just going to quickly show you another way that we can handle the logic that we're currently doing right here. Before we jump into a quick side lesson, I wanted to apologize for anyone who is following along locally. I had a design flaw that I didn't realize I had introduced here, because as I'm recording here in Scrimba, our mini browser here is quite narrow, and the flaw was something that I kind of overlooked. Those of you who have been using a wider screen have probably noticed that things are not aligning quite right. And it turns out it's any of the elements that I have added a max width to. You see, when I have the justify content center on my body, it's taking the center point of the element as it would be if it weren't constrained with a max width. So this paragraph, for example, which we can clearly see is off center from the entire page, if I take the max width off, then it expands to its full width and the center point of it aligns correctly with the center of the page. I can come down here to, let's see, this is my language chips. I also have a max width. If I take that off, then it aligns correctly to the center. I do still want those to have a max width, just so that they wrap in the way that I want. So there's a few different fixes that I can provide. I can either on every one of these put a margin inline of auto, but another fix that I found is we can provide another flexbox to the parent of all of these sections. So that would be the main element. I can say the display is going to be flex, and we're getting a crazy layout right now, but we will adjust the flex direction so that it points downward in a column, kind of like block elements. And then I can use align items to the center. And just like that, we get everything nice and aligned to the center. Because of this, I actually no longer need my display flex or justify content on my body, so I can get rid of those styles, and everything's in harmony. Making the main element its own flex container does introduce a new problem. If I win the game, we can see that our status message is really tiny now. It's being compressed to only fit the space that it has. And so something we might want to add to our section with a game status right here is, and I'll group these with the other sizing properties, we'll say the width should be 100%, but we will also set a max width, and just need to spell that right, of 350 pixels. That is looking much better, and everything seems to be in harmony now. Again, I apologize for anyone who was just wringing their hands at the misalignment. I know that would have bugged me if I were in your shoes. All right, let's jump back in and learn about another way that we can handle conditional rendering. Sure, correct indentation can make our nested ternary look at least a little bit manageable, but come on, these crazy frowny faces are just really pretty awful. I personally don't love nesting ternaries, and I thought it could be helpful for us to see another way that we could handle all of this conditional rendering. It might be tempting to think, well, I can just simplify all of this crazy ternary logic by putting an if-else statement directly inside. However, as it turns out, we can't use if-else statements inside of our JSX expressions like this. And that's because if-else statements don't implicitly return anything. An expression, on the other hand, like a ternary, does automatically return these values. And since they get returned as a JavaScript expression automatically does, then it can get rendered to the page. However, that doesn't stop us from using an if-else statement inside of a helper function. So I'm going to just come up here let's see, maybe right below our game status. I'll create a function that we call render game status. And because I'm inside of a function, I can return something from these functions, and I can use JavaScript statements like an if-else block. At this point, it's more of an algorithmic challenge to figure out exactly how to equate what we have down here with what's going to be in the function. I don't think that's an important part of the scope of this course. So one way I could do this is to quickly do an early return and say if the game is not over, so is game over, then for now, we're going to be changing this later, but for now we're returning null. So I can say let's return null. Because this is an early return from this point on in the code, I can assume that IsGameOver is true. And so I can just separately check, is the game won? If so, let's return, and let's grab this guy right here and put that there. And otherwise, we will return this one down here. Later in this series of challenges, we are going to be finding some of the things that we can offload to a separate file. And because of how tall this function is, it feels like a good candidate for that. For now, we're not going to do that. And I can just simplify all of this by calling render game status. Maybe I should hit save and test this out first. Okay, let's win the game first. Okay, awesome. That's applying the way we'd think. And then we'll go ahead and lose the game. Well, I guess I can't keep choosing correct letters if I want to lose the game. Okay, awesome. Again, this is not a right or wrong way to do it. When I do find that my rendering logic is getting a little bit complex, I'll sometimes prefer to offload that to a function that lives inside the body of my component. We've really been jumping from one challenge to the next. I think it might be helpful at this point for us to step back again and take a quick inventory as to what we might still be missing in our game. Just to reorient ourselves after this whirlwind of challenges that we've done so far, I think it could be helpful for us to take an inventory of the features that we still have in our backlog. If you've gone over to the Figma design, you have already seen that we are planning to do these farewell messages every time the user gets something wrong. And I don't remember if I've mentioned it, but these are going to be randomly chosen from a list of different farewell messages. So we do still need to handle this use case. So we'll say that we need some farewell messages in the status section. We also have a few pretty glaring accessibility issues that we need to make sure we fix. So I'll say we're going to fix the accessibility issues. And maybe just in case you didn't already know this, because it took me an embarrassingly long time to figure this out, but the reason accessibility is shortened like this is because it starts with an A, it has 11 letters in the middle, and then it ends with a Y. You'll also see abbreviations like internationalization, which is I18N, because there's 18 letters in the middle of these two letters. Okay, so we have some accessibility issues we need to fix. We also currently have a new game button that doesn't work, so we need to make the new game button work. We're currently hard coding the word that we need to guess as React, so we need to actually choose a random word from a list of words. And then last but not least, we definitely want to make sure we drop some confetti when the user wins. We'll certainly be making other improvements and little tweaks to the app along the way, but I think this represents a full picture of the backlog that we still have to work on. Maybe this would also be a good opportunity to remind you that if you've been sitting down for a while, maybe it's time to get up, stretch, take a few deep breaths, go for a walk, do whatever it is you need to do to recenter and refocus yourself. I also won't be offended at all if you decide it's time to shut down the computer and pick this up at another time. As they say, we need to sharpen the saw. Once you're feeling refreshed and renewed, let's jump into this backlog and continue making progress to finishing this app. This is a fun game, but let's not forget what's at stake here. Every time the user gets a wrong letter, we have to bid farewell to one of the languages that gets erased from existence. Including this farewell message up in the status bar is your challenge for this lesson. As a help, what I've done is created a getFarewellText function inside of this new utils.js file. All it does is it takes a language as a parameter, it has an array of farewell options, and then it just randomly returns one of them. Now, I'm not going to click on it, but I do have a hint.md file that I have created. If you give this your best shot and you find yourself getting stuck for maybe more than 15 or 20 minutes, at that point you would have my permission to go over to hint.md to see if that hint helps you out. But I do want you to do your best to solve the challenge without using that hint if you can. The time is yours. Go ahead and get started on this challenge. All right, since I assume you have done that challenge now, I'll go over to the hint. And this instructs us that we need to know if the most recently guessed letter was a correct guess or not. If we think in terms of the render cycle for our game, when the user clicks one of the buttons to choose a letter, what's actually re-rendering our app is that we are placing that letter in an array of guessed letters. Guessed letters doesn't indicate if it was a correct guess or not. We are deriving that information elsewhere, but simply by adding it to the array of guessed letters, our app is re-rendering, and then based on that information is updating the display. If the guessed letter was in the word, then it puts it in its correct spot in the word. If it wasn't in the word, then it's killing off one of our programming languages and marking the letter as red as the keyboard gets re-rendered. However, we need a way to know if the last item in that array of guessed letters was a correct guess or not. And by the way, this probably isn't the only way to do it. It's simply the way that I came up with, but I'm super open to feedback. If somebody comes up with a more logical or easier to reason about way, then I would love to hear it. Come over to the Discord. You can @mention me. You can even send me a DM on X if you'd like. Okay, so let's come back to our app. And maybe just to get started, I'll go ahead and import this function. We'll import the get farewell text from /utils. And maybe what we can do is derive whether or not the last guessed letter was a correct letter. Or maybe since I'm going to display this only if the last guessed letter was incorrect, we'll go ahead and say const is last guessed letter, or let's just say last guess, incorrect. Okay, well, I can get access to the last guessed letter by finding the last item in our guessed letters array. So maybe I'll do that separately just so that I can kind of separate my logic here a little bit. Let's say last guessed letter. That is going to be equal to the array of guessed letters at the index of the array of guessed letters dot length. But then we have to do -1 just because of the 0 indexing. So this will get me the last guessed letter. It doesn't indicate whether it is correct or not. But now what I can do is I can check to see if the current word includes the last guessed letter. And because this is a Boolean as to whether it's incorrect, I'm going to say it does not include the last guessed letter. Let's console log this. Is last guess incorrect? We'll hit save. Oh, interesting. We did show true when the app was first rendered, even though we haven't made a guess yet. And that would be because guessed letters is an empty array. Guessed letters.length is 0. And so we are trying to index into guessed letters at the index of -1, which is going to be undefined. So maybe we can just protect against this by making sure that the last guessed letter is a real value. And only then will we check if the current word includes the last guessed letter. Okay, let's try this again. Okay, undefined, that's going to work for us because it's a falsy value, and we'll pass any of the conditional checks that we have later. Well, actually, before we continue on, let me try this. Okay, so we get yes, it was an incorrect guess as the most recent one. It should be another true, and then let's do a letter we know is in there. False. Okay, good. That is correctly telling us if the most recent guess was incorrect. Okay, so what do we do now? Whenever the most recent guess was an incorrect guess, then we want to display the farewell message. We wrote a helper function to help us determine what should get rendered in that status section right here in render game status. And we were just returning null if the game is not yet over. But what we can do now is to also check if the last guess was incorrect. So we can say if the game is not over and the is last guess incorrect is true, then we can see we just have a single line here. Maybe we'll just render this as a paragraph. So I'll return, I need my return here, return a paragraph. And for now, let's just get the styling correct. I'm going to just say bye. We'll add a class name, and maybe we'll say this is a farewell message. And over in our CSS, we can select the farewell message. Let's see, game status. Here's one lost. Let's go ahead and, oh, look, this is probably going to select the paragraph we already have. That's okay. Actually, yeah, let's duplicate this one and then make sure that the paragraph has a class of farewell message. And I'm just going to paste in some of the styles that you can find in the design, which gives it a dashed border, a purplish background color. It makes it italics, bumps up the font weight a little bit. And well, let's just see what this looks like. I haven't yet saved over here. Let's make sure, yep, we're returning this. It's just going to say bye for now. Let's hit save. And oh shoot, I've made a mistake in my logic here. And let's think about it. Okay, so the game is not over. The last guess is not incorrect, so we're not considering it correct, but it's not incorrect. So then it skips this. It comes to if the IsGame1 is true, that's not going to be true. So then it's just hitting the else, and it's telling us that the game is over. You know what, let's, instead of having this else here, let's explicitly check if the IsGameLost is true. Then we'll do that, and then otherwise, at the very end, after all these returns, if none of them hit, then we will return null. Okay, let's try again. Oh, awesome. Okay, our game over is gone. Let's go ahead and hit Z. And oh, look at that. I just realized I don't want to put my styles on the paragraph. I want to put those styles on the game status. This is a mistake on my part. I think I'm just going to leave it here in the recording because it's a very common thing. So we can go back and fix this. Let's see, we have some styles that are already being applied dynamically with CLSX. Let's go ahead and just duplicate this. We'll change this to be maybe a class called farewell. And let's take the section specific styles, which are the background color and the border here, and we'll just replace that one. Clean this up a little bit. The font style and font weight, I believe I still want to be sitting there on the text itself. And so now we will go over to where we have our CLSX call right here, and let's add another one called farewell. And let's think. This is going to apply if the is last guess incorrect, but I think we might also want to make sure that we're not conflicting with the is game lost styles. And so let's just make sure that the is game over is not true and the last guess is incorrect. Let's try this out. We'll get an incorrect guess. And okay, well, our styles are applying. It's floating up there at the top a little bit. Let's go check that out. And right here, yes, it looks like we're doing a display of flex direction column. We're doing align items, which in the column direction makes it centered horizontally. But in this case, we will also need to do justify content center. And okay, great. Just for kicks, let's refresh again and see if the other message is still working, even though we changed the justify content. And so I'll need to win the game real quick. Okay, good. That's looking great. Let's get rid of that console log that's running every time. We'll clean up our challenge text. And just like the message says, well done. There's a lot of moving parts to this challenge. We had to create a couple more derived values so that we could more easily check to see if the last letter was incorrect, and therefore displaying that message. The last thing we need to do is call our getFarewellText function. Maybe I prematurely deleted the challenge text, but that's the last thing we need to do. Instead of it just saying bye, we want to randomly choose one of those farewell messages. So let's see, right here it's saying bye. Instead, let's go ahead and call getFarewellText. And let's see, we need to call this function, but it's expecting the language to be passed in. So how can we get access to the language that was just removed? Well, let's see. One language is going to get removed for every incorrect guess. And I believe we derived some state, for the wrong guess count. So what if we index into the array of languages at the index of wrong guess count, and then I think it would have to be -1 because languages is 0 indexed. Let's go ahead and give that a try. So right here, get farewell text. This is getting really long. Let me put these on its own lines, and I'll put the class name there. We'll just kind of format this a little bit. Okay, so I can call getFarewellText. I need to index into languages to try and find the correct language in this array. I want to index by the wrong guess count, and then that's going to be -1. And then we have to remember too that languages is an array of objects, and so if we want the name of the language, we're going to have to call .name. Oh boy. Okay, let's see if that works. Let's get it wrong. And RIP HTML. Sad day, but also happy day. It's working. That's quite a roller coaster of emotions we're on. Great work on this challenge. I know that there were a lot of moving parts to this, and something that seemed as simple as just display a simple message here ended up being quite a bit of logic. Hopefully that went well for you, that we're really building something that has a lot of moving parts. I think I don't need this on its own line, actually. That's good enough. And we can check one more item off of our backlog. We're getting closer to completing this app. Before we jump into fixing some accessibility issues, I added another item to our backlog, which is to disable the keyboard when the game is over. Right now, when the user completes the game, let's go ahead and win here, they can continue to guess letters and lose the game, which, wow, gives us some pretty strange results here. In order to stop the user from continuing to guess, we can simply disable every one of these buttons whenever the game is over. This is just going to be a super quick challenge. It's your task here to do exactly that. So go ahead and disable the keyboard when the game is over. Let's see, let's come down to our keyboard elements, and inside of the code for our button, we can simply say disabled is equal to is game over. So let's hit save. Buttons are still working, which is good because the game is not over. And okay, just like that, we can no longer click these buttons. Maybe let's just add a little bit of styling here. So let's go ahead and say inside of the keyboard, the button when it's disabled, let's give it a cursor of not allowed. And then we can actually set some opacity on it just to make it a little more obvious that the keyboard is disabled. Okay, well, doing this brings us into the next part of our backlog, which is to fix some accessibility issues. I was planning on starting that in this same lesson, but I think just to keep everything organized, we are going to do this in the next lesson. One thing that's really important to do as you're building your app is to try and keep accessibility in mind, specifically when you're choosing what elements to put on the page. For example, we made sure to make every one of the keys in the keyboard a button element because we get quite a bit of accessibility benefits for free by using a semantically correct button element instead of, for example, just making this a div that is clickable. Buttons automatically come with their own focused state, the ability to tab through them, and you can make divs accessible, but you just have to do a lot more work to get that done. However, when we're working in React and we're dynamically rendering or removing things from the page, it's still really important for us to keep in mind what is changing and what might be difficult for assistive technologies to keep up with if we don't specifically cater our code to those needs. The thing that got me thinking about how we need to disable the keyboard when the game is over is that we want to also tell assistive technologies that those keys are disabled. There are some screen readers that will announce when a button is disabled, but some of them don't. And so we can add a dedicated ARIA disabled property. If we can find our buttons here, okay, right here. We have disabled it, but we can add an ARIA disabled. And we could decide to set this equal to IsGameOver in the same way that we did with the disabled property. However, when we're thinking about someone who is using the tab key to tab through all of these letters, maybe a better user experience would be to disable the ones that have already been chosen. To do that, I could simply say something like the array of guessed letters includes this current letter that we're looking at. And I guess at that point, it might be a choice to decide if that's also when we want to disable the keys in general. We've already included some logic that doesn't allow the user to keep trying to add the same letter to the array of guessed letters. So I think I'll probably just leave it the way that it is. Thinking about the user experience from the point of view of someone using a screen reader as well, when they're tabbing through these, the screen reader will say the letter that is currently being focused in the button, but it might be just a slightly better experience for us to label it with maybe the word letter beforehand. So it actually says letter A, letter B, letter C. I guess at that point it might just be a preference. I'm not really sure, but let's go ahead just for the sake of it and add an ARIA label. And this will simply say the word letter followed by the actual letter. Okay, so that should make the user interactive part of it a lot more usable for those using assistive technologies. We also need to take some time to look at any portions of our site that are being dynamically rendered. Well, one of those is the status message that pops up here. Screen readers are not just going to automatically announce things that get added to the DOM by React, but fortunately there's a way that we can mark certain portions of our app as sections that will be live updated. So we chose to render this with a function, which is right here in render game status. But the parent of these elements is just down here in the markup right here. This section with the game status, what we can do is add an ARIA live region to it and say that it is polite. Polite just means that it's not going to interrupt the rest of whatever it's currently reading to announce changes to the section. It will kind of cue it to the end of any changes that the screen reader is currently reading. There's also a role property, and we can essentially say this section's role is to be a status. Let me put these on their own lines. And doing this will give us some additional accessibility benefits. Okay, well, let's think about another part of this app that kind of acts like a status and is definitely something we would want to have read to our users if they're using a screen reader. Well, I think it's going to be pretty important that they have some idea of what the current revealed status of our word is. And while we could just surround let's see, this is our actual word. We could surround this in an ARIA live region, just like we did up here above with the game status. However, because this is such an important part of the game, I think we could put a little bit of extra effort into what gets read out by a screen reader when this is being updated. Now, because this isn't a dedicated course to accessibility, I am just going to kind of explain the code that I'm writing as we go, and hopefully it will give you some ideas of how to improve your own apps in the future. Something that we can do is we can create an entirely separate section whose sole purpose is not to display anything visually, but to be read out loud by a screen reader. And then with CSS, we can just completely hide it from the DOM. So maybe right below our word here, I'm going to add another section. And I'm going to add some CSS that will essentially just completely hide it from the DOM. We'll give it a class name of SR only for screen reader only. Then in our CSS, I'm going to just paste in a screen reader only class that I have defined in another project. It essentially is removing it from the visible area and doing everything it can to make sure it never shows up. Then, just like we did in our status section, we can also put an aria live of polite and a role of status. Okay, let me put these on there on lines 2. And oh, I said dash instead of equals. Okay, so now anything that I put inside of this section is just going to be read out by the screen reader. And that will happen anytime there's an update to this section. So maybe the first thing I'll do is to put a paragraph that will just read out what the current word is. And because this will never be there visually, I can actually type in the text that I want the screen reader to read. So I can say something like the current word, colon, and then I can just have it read out each individual letter of the current word. So let's see, we have our current word. We'll add a dot split to turn it into an array, and then we can map over it. And for each letter in that array, if the letter is currently revealed, or in other words, if the array of guessed letters includes the current letter, then we'll just have it read out the letter out loud, and not the literal string letter, but the letter itself. And otherwise, well, it won't read anything out. Although I have found that if you have an empty string, it's just going to ignore it. So what we can do is actually just have it read the word blank. So it'll say something like R blank 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 blank. Another thing that I have found as I've played around with screen readers is that if you add a period like this, it will add a little bit of an extra pause. So if there were multiple letters, instead of saying REACT just super fast, I think this might give it just a little bit of a pause between them. I guess don't quote me on that. I'm not 100% sure. It's been a little bit since I've played with it. Okay, well, let's see. I'm still mapping over this, but I'm not actually turning it into a string that it can read out. And let me put a period here too, just in case that works the same way as I was describing before. But now we can join things back together, and we'll put a little bit of a space in there just to make it a little more readable for the screen reader. Okay, I know this looks a little bit crazy. We could probably offload some of this to a helper function if we want, but I think this is going to get the job done for now. There's actually a little bit more that I want to add to this section, but since we've bitten off quite a bit in this lesson, I want to give you a chance to review what we've done, maybe think about other apps that you have created, see if there's any of these accessibility rules that we've talked about that you could apply over there. And then there's one other thing I want to add to this section, which we're kind of treating like a generic screen reader status update section. And so we'll do that in the next lesson. Another accessibility user experience improvement that we can make is not just to reread out the current state of the word and the status that we have up above, but we could simply announce whenever a letter was guessed correctly or incorrectly every time the letter is guessed. So after the user selects a letter, we could have the screen reader read something out like, correct, the letter R is in the word, or sorry, the letter Q is not in the word. We could even add something that says you have 6 attempts left. Now we could choose to do that in a completely different section, but I think just before this paragraph, I'm going to add another paragraph that will announce whether or not the previously guessed letter was correct. So let's go ahead and add a paragraph. And what we'll do is check to see if the most recently guessed letter is in the current word. We'll have it read out correct the letter, whatever is in the word. Otherwise, we'll have it read the negative side of that statement. And I think we are saving the last guessed letter. Yeah, we actually created a separate variable up here so we can get access to that. Awesome. So let's see, right down here, we're going to check to see if the current word includes the last guessed letter. And if it does, this is where we can have the text of the paragraph just read out what we want it to say. So correct, the letter, and then this will be the last guessed letter, is in the word. Otherwise, we can put our message that says, sorry, the letter, last guessed letter, is not in the word. And then whether it was right or not, we could say something like, you have, we need to know how many attempts they're going to have left. Let me just hardcode this. We'll say you have 4 attempts left. And let's see, the number of attempts that they have left is going to be we had figured something out up above. And yeah, we were using languages.length -1 as our number of incorrect guesses that we're allowed to have. So I guess we could just use this again, although I kind of want to just derive that value so we can use it elsewhere. Maybe just right here at the top, I'll say something like number of guesses remaining left. Number of guesses left is equal to languages.length and then -1 because we need to leave assembly as the last item. Okay, so then number of guesses left. Let's see, we can just say this. And then with that new derived value, we can come down to our screen reader only section again. And then instead of putting in the hard-coded for, we'll say num guesses left. And with just those few updates, maybe a dozen or two lines of code, we have now made this app much, much more accessible for those using any kind of assistive technology. Of course, it's also important to make sure you go through and make sure that your contrast ratios are good enough and everything like that. But what we've done here marks a huge step forward in the accessibility friendliness of this app. Right now, another developer coming to this section might pretty easily miss the class name of SR only. And so I think it can be helpful to include a little comment here that can say that this is a kind of combined, visually hidden ARIA live region for status updates. Okay, let's come up to our list here, and we're just going to mark this one off. There likely are other improvements we could make. There's always more that you can do. But we just have 3 more really small features to add to our game, 2 of which are crucial for the functionality of the game, and 1 of which is just going to be a really fun way to wrap things up. So next, let's jump onto the next item in our backlog. And actually, now that I'm looking at this, I'm going to swap these 2. I want us first to choose a random word from a list of words. So that's what we'll be working on next. This should be a pretty short and sweet challenge. We are going to make it so that a random word is chosen when the game starts. Right now we're just hard coding React, but we're going to make it so that a random word will get chosen. I've created a new file called words.js that has close to 500 words in it. I tried to weed out anything that was fewer than 5 letters and greater than something like 9 letters, I think. And so your task is to come over here to utils.js and write a new function that will randomly choose one of the words from that list of words. I've already imported the words right here, so you can use it in your function. This part is just sort of an algorithmic challenge, nothing very React specific to it, but then I want you to import that function into this file, the app.jsx file, and figure out where to use that function. Go ahead and get started on this challenge. All right, let's come over to utils.js, and we will export a new function that we'll call getRandomWord. And simply enough, all we need to do is get a random number that's in the index of the array of words. So let's create a random index and set that equal to math.floor, math.random, and then we can make sure that it's limited to the length of the array by multiplying this by words.length. Then all we have to do is return words at the index of our random index. Easy peasy. Okay, let's come over here to our app file. And from utils, we're already importing the get farewell text. Let's go ahead and also import get random word. And we're really flying through this challenge. We've already finished 1 and 2. Let's figure out where to use that function. Well, we were hard coding React as the initial word that we were using. And instead of using React, we're basically going to be turning on the game now. We're going to call getRandomWord, and let's try playing our game. We'll hit save. And look at that, we no longer have a 5-letter word here. Ooh, this is a long one. This is 8 letters. Let's see. Usually longer words in Hangman are a little bit easier, but I'm not doing very well here. Ah, that's why there's 2 I's. Sorry, HTML, CSS, and JavaScript, we have already lost you. Let's see, what could this be? Ah, I think this is military. Sure enough. All right, well, we're still left with TypeScript, Node, Python, and Ruby, so we did pretty good. Military, yay, we won. Now, some of you might have remembered that if we are initializing state by calling a function like this, technically every time we cause a re-render in our app, React will rerun this function. Even though it's not going to use its returned value to change the state again, it is calling this function again every time. This getRandomWord function is not a very expensive function, but it doesn't hurt us to use lazy state initialization, which we learned in the last section, by simply wrapping this in a callback function. This way, on the very first render, React will call this function and it will get our random word and set the initial state. But on subsequent re-renders, it's just going to simply ignore this function. That way we're not running any extra operations that we don't need to be. Awesome. Let's clean up this challenge text and mark this next one as completed. The next thing we'll be working on is giving the new game button some love so that clicking it actually resets the game. This is going to be another short and sweet one. That's how you know we're really tying off the loose ends of our game here. Your challenge is to make the new game button reset the game. Go ahead and get started on this challenge. All right, well, let's hook up our button first, and then we'll write the logic for it. So maybe just right here, I'll add a new function that says start new game. And I'll just console log start a new game. That'll do for now. We'll go ahead and hook up our button, which is way down here at the bottom for new game. We'll say on click, it's going to simply call start new game. Okay, let's hit save. And I guess we need to actually play this game now in order to display the new game button. Oh no, this is not a good start. Oh, I don't need to win this game for this to show up. I can just lose the game. Okay, let's go ahead and click new game, start a new game. Perfect, okay. Oh, I just thought of another feature we need to add. We need to display the word after the game has been lost. Otherwise it's so anticlimactic we never get to figure out what it was. Anyway, let's stay focused. Up here where we are resetting the game, okay, we don't need to console log start a new game. There are two things that we need to update. First of all, we need to get a new random word because this one's been used now. And secondly, we are maintaining a list of guessed letters and we need to empty that back out because we want our keyboard to refresh. We don't want to display any of those letters to the new word and so forth. So we can use our state setter functions to set the current word. And of course, once again, we will call getRandomWord. And then we will say set guessed letters to an empty array. Once again, short and sweet, this should be working. Let's go ahead and just lose the game right now. These last letters tend to not be correct. And we'll click new game, and perfect, everything starts over. Okay, I'm actually going to add that item to our list here. We need to reveal what the word was if the user loses the game. In the meantime, we can mark this one off. We are so close to the finish line, I can practically taste it. So let's hurry on to the next challenge. This one will require a little bit extra thinking compared to the last two challenges. So what I want you to do is to reveal the missing letters of the word if the user loses the game. So for example, let's just lose the game real quick here. Oh geez, I'm not losing. Okay, here we go. We don't want this to be a mystery. We want to reveal what the word was to the user. So you'll have to think through the logic of how these letters get displayed, and if the game is lost, you'll want to reveal the missing letters. And as it mentions here, for now, let's go ahead and style them with the same red color that we use for the button keys when they're incorrect. Go ahead and get started on this challenge. All right, well, let's go down to where we are figuring this logic out of how we display the letters. And that's right here when we're mapping over the current word. I think the first thing I'll do is figure out the logic to display the missing letters only when the user has lost the game, and then we'll worry about styling them. The most concise way I could think to do this wouldn't be to conditionally render one span or another, depending on whether they missed that letter and lost the game or not, although that would have been a completely legitimate way to do it if that's how you decided to solve it. Currently, as I'm mapping over the current word, I am publicly displaying that secret letter if it is included in the guessed letters. What I could do is simply come up with another variable that will also display this letter if the game is lost, so that if the game is not lost, it will only display it if it's in the guessed letters, and if the game is lost, it will just display all the letters. So let's go ahead and do that. One thing I can do is just create a new variable that's called maybe something like should reveal letter. And I want the letter to be revealed if the game is lost, just automatically display the letter, or if the guessed letters includes the letter that we're currently mapping over. Oh, and I was using an implicit return before, so I'm going to have to fix some of my brackets here. Let's see, I'll move this down here. We'll return the span. Yeah, there we go. Okay, so instead of doing this, we'll say should reveal letter. And let's go ahead and lose the game and see if it shows all the letters. Well, this is a long one. All right. Holy cow. 3 T's. Okay, statement. Yes, perfect. The word was revealed. Now, because CLSX is so powerful, we can use it to determine if the letter was not in the guessed letters array, and if the game is over, then we can dynamically add a class name. So let's see, right below here, let's go ahead and say maybe the letter class name is equal to CLSX. And the first thing we want to make sure is that the game is lost. We want to add a class name if this letter was not included in the guessed letters. So we'll say if not guessed letters dot includes the current letter. Then we can add the class, let's call it missed letter. I'll go ahead and make sure to add my class name of letter class name. I'll hit save and come to my CSS, and I guess we're already here. So this rule right here, the span, is what we're trying to attach to. Let's add a class for missed letter, and we will just change its color to be the red color from the design. Okay, let's go ahead and lose this game. Wow, that looks so good. That is a much better end of game user experience. All right, the last challenge, and arguably the most fun one, let's make it so that our confetti will drop when the user wins the game. This challenge kind of feels like in golf when you just barely missed a putt and all you have to do is just send it home. We've literally done this exact same challenge in the last project at the end of Tenzies, so this should feel right at home to you. I've already installed the React confetti package and imported the confetti component here. All you need to do is trigger the confetti drop when the user wins the game. I'll hand it over to you to send us home. I guess before I walk through this challenge, you may have noticed that I did have to downgrade my version of React back to React 18. That simply has to do with the fact that React 19 is not officially launched yet. It's still on the release candidate version, and it seems like the React confetti package is not yet working with React 19. All right, let's do it. We'll go down to our markup down here below, and it doesn't really matter where we do it. I think I'm just going to have it be rendered right here at the top. We'll call this a glass half full kind of decision. And we'll say if the game is won, then we'll go ahead and render confetti. Now I actually am going to add some of the options to confetti, the props that you can pass to it. Specifically, I'm actually going to turn off the infinite confetti by setting recycle equal to false. And you can specify the number of pieces. These are just things you can find from the documentation for React confetti. And I'm going to bump it up a little bit to 1,000. Let's do our best to win this game. This would be a little anticlimactic if I lose now. Oh, I'm on a roll. Look at that. I think we need another vowel in here. Oh, yeah. Ooh, I think it's distance. Here we go. Before I click the N, it's going to be anticlimactic for you as the viewer because you're not going to be able to see the canvas elements of the confetti dropping, but I can tell you that it is awesome. What a celebration. I guess you'll just have to hit refresh and play the game for yourself. Now, surely there are other improvements we can make to this game, but before we jump into a recap of everything that we did with this game, I want you to take a second and just look at this code base. This is a hefty code base. Let me go ahead and check this off too. Obviously, this doesn't compare to any enterprise level apps that you're making, but this definitely represents the longest app that we have built in this course, and it looks and works amazing. Huge congratulations to you if you made it through the entire React course up until this point. That is an amazing accomplishment. We are going to celebrate that even more in the wrap-up that we'll do in the next scrim and recap everything that we've learned. Well, you've done it. You've saved humanity from having to suffer through writing assembly for everything. In all seriousness, this was a complex project, and you have done an amazing job working through all of the challenges along the way to building it. And just like the Tenzies game, this is another one that will be super fun to share with your family and friends. If you want to keep the fun going, there are a few extra credit ideas that I came up with. First, you could simply display the remaining guesses count. We do have the visual of the remaining languages, but maybe just having the number of remaining guesses allowed could be a helpful UI addition. We do celebrate the win with the confetti component, but you could consider rendering some kind of, I don't know, anti-confetti when the game is lost, or maybe another animation that really makes the user feel that loss. You could also implement something like a chess timer that starts when a new game starts and causes a loss if the time runs out, adding a little bit of extra pressure to the player. There are a couple things that you definitely should do. The first one is you should deploy this live online so you can share it with other people, including putting it in your portfolio. And secondly, you guessed it, you should head over to the Today I Did channel on the Scrimba Discord server. Even if you don't have it posted live online to share a link with other people, simply leaving a message there to celebrate your win is a great way to engage with the community. Amazing job completing this project. Hey, you did it! We're here at the end of the course. You should be so proud of yourself for finishing, because assuming you've done all the challenges and projects in this course, you are well on your way to becoming a proficient React developer. As I said in the very beginning of this course, my philosophy is that the easiest way to get good at something is to put in the work, to do it the hard way. And considering you are here at the end, having done all the projects, you have put in the hard work, and I can promise you that it will have been worth it. Let's take a look back on the projects that we worked on in the different sections of this course and do a quick recap of what we have learned. In section 1, we started with really basic static pages in React so that we could build a solid foundation to support the rest of our learning in React. And we began that section by first learning why we even care about React in the first place. We talked about how React is declarative, making it a much better developer experience, and how React is composable, allowing us to build reusable pieces that can be combined together to make a masterpiece of a web app. We touched on setting up a new React project, not only in terms of the code that you have to write, but also how to do it on your local machine. Then we learned about React elements and how JSX was created to make creating those React elements a very familiar experience, similar to writing HTML. Then we learned about the crux of composability in React by learning about custom components. Custom components allow us to co-locate logic, markup, and styling all in the same place to create a custom reusable piece of code. And then, of course, we needed to make sure that we added some styling so that we weren't just throwing around ugly components. With that knowledge, we were able to build our first static React Facts web page. From there, we moved on to our second section where we built a travel journal. What set this travel journal apart from the React Facts project is that it was data-driven. We really drove home the concept that reusability is extremely important, and learned how we can take our React components, pass props into them so that they could be reused in multiple different ways. Once we knew how to pass props into a component, similar to how you pass parameters into a function, we learned how we can use vanilla JavaScript array methods to create components from an array of data. Doing this allowed us to put the data for our travel journal in one place and simply map over it to create the ultimate view on the page. This meant that if we wanted to add new entries to our travel journal or change a detail of one of the items, all we had to do was change it in one place, the data. Then we really dialed it up to 11 and jumped into the Chef Claude project in section 3. This section was entirely dedicated to building interactive web apps, whereas before we were working with static, read-only pages. Now we're able to respond to the user's inputs by learning about event listeners and how we can update our app based on the interactions of our users. We learned about state, which allows us not only to save information between one render and the next, but also allowed us developers to focus on updating the state correctly and letting that flow to the UI, which is what React is intended to do. Changes to the state will automatically update what the user sees. We learned about conditional rendering, how we can display or not display certain parts of the web page based on conditions. Then we learned about forms and how React 19 enables an entirely new approach to forms, which is much more closely aligned with how the native web platform handles forms. And we took a chance to dabble just a little bit into different state management strategies, although state management is a rabbit hole that would probably require an entire course of its own. Then we had a lot of fun building our meme generator and learning about side effects in React. We began the section by talking about controlled components, which are essentially the way that React has approached dealing with forms all the way up until very recently at the time of this recording. But there are scenarios where controlled components can still be useful. In our case, we wanted to update our state so that the top text would reflect on every keystroke what the user was typing into the input box. Then we talked a little bit about how React has a philosophical basis in functional programming. We touched on the concepts of immutability in React and how our components shouldn't affect any outside systems from themselves. However, the purpose of the side effects section is to learn how we can use an escape hatch from that functional programming paradigm when we absolutely need to. And the way that we did this in our meme generator project was to fetch some data as soon as the component loaded. Having a so-called escape hatch, which gives us a chance to safely handle side effects whenever they're absolutely necessary, turns out not only to be a really important thing in React, but also one of the more misunderstood aspects of React. Then we got to the place where the rubber met the road, and that was in our capstone projects. We built 2 back-to-back games that were both really fun to build and legitimately are fun to play. Hopefully, looking back at all of these sections gives you a really strong sense of appreciation as to how much time and effort you put into this course. This would be a perfect opportunity for you to head to the Today I Did channel on the Scrimba Discord server and post a message, dare I say brag, about this tremendous accomplishment. Now, I don't want to just leave you hanging at the end of this course, so I wanted to give you some ideas of what you could be working on next. Naturally, I'd first like to put in a plug for my Advanced React course here on Scrimba. The Advanced React course is the natural progression from where we left off at the end of this course. In that course, we dive deep into reusability in React and learn a bunch of new ways that we can turn our reusable components into even more reusable components. We learn how to build single-page applications using the React Router library, and we learn all about performance in React and how we can improve the performance of our React apps. Another really important topic you could move on to if you haven't already learned it is TypeScript. And good news, I also have a TypeScript course here on Scrimba, and it is completely free. I already mentioned React Router, but you could focus specifically on learning the React Router package. At the time of recording, React Router is about to release version 7, which is a completely new version of React Router. If you're looking to go more into a full-stack realm, Next.js and Remix are awesome frameworks that you can use to be building not only the front ends, like we've learned here in React, but also the back end, so you can handle server interactions, data, caching, cookies, and all of that. If you are interested in backend, you could go the direct backend route by learning Node.js with or without Express, all to help you build REST APIs that your front-end React apps can consume. And last but certainly not least, you could learn about deployment and how you can get your apps live on the web for your friends, family, and potential future employers to check out. My name is Bob Sorol. It has been my absolute pleasure to teach this course and guide you through learning React. My username pretty much everywhere on the web is Bob Zorol, although these days I do tend to be most active on X. If you click my username here, it will take you to my profile. I would certainly appreciate a follow. And folks, that's all I have left to say, except for congratulations on completing this Learn React course.
Hi, I'm Tom from Scrimba, and in this section, I'm going to take you through a couple of really useful VS Code and Chrome browser extensions, which are going to make your life as a React developer just a little bit easier. As we look at these extensions, we're going to be working on this layout. This is actually a screenshot right here. So the company is Urban Nest, and this is the dashboard. And on the dashboard, we've got 4 product cards and 4 user detail cards. These contain dashboard type activities like changing billing address or changing password. Now, if we have a close look at this, you can see that we've got the username right here in the header, also here in the dashboard title. We're using it again down here. And you might also notice that we've got the location here, and that is going to affect which currency symbol we use. And we've also got the user's email address in this card right here. So you're starting to get a feel, hopefully, for the way that props are used in this project. Now, at the moment, we're working inside Scrimba, and I've already written some of the code. Let's just open up the mini browser and see where we are. So we've got a header and we've got a footer, but we haven't got any of that content in the middle. And the reason for that is that we've got this dashboard component, but it's completely empty. So what we're going to work on is getting this dashboard component sorted out using some browser extensions. And to do that, I want to move everything over to VS Code. Really easy to do in Scrimba. I just click on Settings, download a zip. That's downloaded a file. And there we are, we've already unzipped the file, and I'm just going to change this name to something more useful, and I'll call it Urban Nest. And now let's head over to VS Code and open up this folder. So it was in Downloads, Urban Nest. Okay, we've got all of our code here, and we can just follow the instructions inside readme.md to start the server. So we just need to do npm install and npm start. Let's open up a new instance of the terminal. So first npm install, and that will bring in all of our packages. And then npm start to start the server. And then we can just click on this link, and there we are open in the browser, and we can see we've got the header and the footer. Okay, let's just take a quick look at the code we've got so you understand how this layout works. We start off with app.js. That is bringing in the header and the footer. Also in here, we've got some state. This is just set up with me. So we've got my name, my email address, my location, and my age, which is honestly not entirely accurate. And then we're just rendering out the header and the footer components, passing in the props that they need. Now, there's nothing particularly strange going on. The header is basically what you'd expect. We've got this nav element, and then it's right here that we're using the username and the location. And if we flip back to the browser, that's what you can see right here. Now, down in the footer, it says follow us on Instagram. That's kind of important. If we go to the footer, we've got this cheeky little bit of ternary right here. And I might just make that a little bit clearer by bringing it down onto a couple of lines. So what's going on here is that we're checking the age, and if it's greater than 50, we're inviting them to follow us on Facebook. If it's greater than 12, we're inviting them to follow us on Instagram. And if not, so they're under 12, we're inviting them to follow us on TikTok. And if we just head back to app.jsx, I said that my age was 30, and that's why we're seeing Instagram down here, but we could change that. And now it says TikTok. Okay, let's put that back. Now I can still show you the screenshot that we've got. We should have it right here in images. And that's just going to show us what we're working towards. So we've got these 4 product cards. We've already got a component for that right here, product card.jsx. We're reusing that 4 times. And then down here, we've got the user detail cards. Again, we've already got the React in there. So we've got all of that code available to us. We just need to put it to good use in dashboard.jsx. So the first thing we need in dashboard is a functional component, and that brings us to our first extension. Adding an extension in VS Code is really easy. We just come to this icon right here, or you can go to Views and Extensions. And then in here, you can just search for the extension you want. You could just use a keyword and see what comes up. I actually know the one I'm looking for, but if I put in React, it's this first one which comes up. It's ES7 plus React Redux React Native snippets. A really snappy name. All I need to do is click Install. A couple of things to notice on this page. It's got nearly 13 million downloads, which is great. It's also well reviewed. And we could scroll down and see a bit of information about it and what features it's got. But I'm just going to give you a quick demonstration. So let's just close that. Come to dashboard.jsx. Now, I'm going to use a key binding, and in VS Code, there are loads of key bindings. It just means key combinations that bring up some kind of shortcut. I'm going to use Command, Shift, and R, but if you're on Windows, you would actually use Control, Alt, and R. What that does is it brings up this pretty fiendish looking menu of all of these options, and these are all code snippets that this extension can give us. So we've got stuff here which is both for React, for Redux, and for React Native. Some of it is legacy, so you'll likely never use it. Some of it is highly complex that you probably haven't come across as yet. So we've got, for example, HOC, which stands for Higher Order Components. When we click that, it gives us the code we need. But hey, that's getting a little bit ahead of ourselves. So again, Command Shift R, and let's actually do something useful. What we want to create here is a functional component. And so we can use this search functionality, and I've put in functional comp, and then down here at the bottom creates a React functional component with ES7 module system. That sounds good. Now we could just click on this right here, but as we're going to be reusing this a bit, why don't we try and remember these 4 letters, RFCE, and that stands for React Functional Component, and then the E is for export. We use that just by typing it right here in the editor, React Functional Component, export, hit enter, and look, there we are. It's made a functional component for us, and it's actually taken the name dashboard from the name of the file, so we don't have to. So that is a nice, really quick way of setting up a functional component. Now, I should give you a warning here that if you rely too much on these automated code snippets, you might end up in a situation where you can't even write very basic React code like a functional component. You could end up looking pretty silly, for example, in an interview environment. So do make sure you actually know the code that you're generating automatically. That is the best way to use a tool like this. It should just be for saving time. Okay, let's quickly pop back to our screenshot, and we can see that we need a dashboard right here. That's going to be inside an H1. So let's return that here. We also had the name of the user, in this case, Tom's dashboard. So let's take that in as props. And I'm actually destructuring the props right here. So I'm using username inside the curly braces, and then we can use it right here. We don't have to say props.username. Now the dashboard is going to have these 4 product cards, and we've got the data for the product cards right here in this data folder, productdata.js. Now we also need to use productcard.jsx. So we've got some importing to do. And to be honest, importing can be a real pain because you can end up with some really long relative paths because you've got a heavily nested file structure. It can be quite confusing and really difficult to debug. So we're going to use a really useful VS Code extension, which is going to help us with importing. Now, the snippet that we used before gives us this import statement that we don't actually need. So let's delete that. And now let's investigate an extension which will help us with importing. And the extension I'm looking for is called auto import relative path. This is the one right here. So let's click install. And if we just clear the search box, that will take us back to our installed extensions. What you'll notice is that we got 2 for the price of 1. We've got auto import relative path and drag and drop import relative path. And it's this one that I'm really interested in, although they come together. So let's just go back to the files. And what I'm going to do is take this component that we want to import. I'm going to drag it over. Now, if I let it go now, it's just going to open the file. But if I put it in position, hold down the Shift key and then release the mouse button, there I get our full import statement, including the relative path. This is a really short relative path, so it wouldn't have been that much trouble to write it ourselves, but it's done it for us. All we need to do is update the name. And now we can use the product card component. But in order to use it effectively, we need to get access to this data. We're going to be mapping over that data. So let's import that next. And again, I'll just drag it and hold down Shift and drop it in. So we want to import product data from, and then we've got the relative path. This one a little bit more complicated because it is in a different folder. So that has saved us a little bit of cognitive load. Okay, let's map over this data. So I'll set up a const right here inside the component, and I'll call this const product cards. And then we'll take product data, call the map method, and that will take in an arrow function with a single parameter, which will be a product. And let's bring this down onto a new line because we've got quite a lot to do here. So for each product, we want to return to this array an instance of our product card component. And that is going to need some props. Let's just have a quick look at the product card component. So each one is an article, and inside we've got a card title, an item name. We've got a currency symbol, which we're sorting out right here based on the location. We've got the price. We've got the source for the image and the out text. So we need to bring in all of this. And let's actually just copy this list. And we need to remember when mapping over data and creating these components that each one needs to have a key prop. And the key prop, if we look at the data, is going to be this ID. So it will be available at product.id. And actually, most of these are going to come from product. Location is the exception. So let's just put product in these 5 props. And then location, we are taking in app.jsx. So we've got it set right here. When eventually we add in the dashboard component, we'll be passing it down. So let's bring it in right here and we should be done. So let's just take our product cards and we're going to render them down here in this return statement. And they're going to live inside a section. And that section needs to have the CSS class name of product cards container. We've got an error here, and that's because we're no longer rendering just one thing, so we can just wrap everything here in a fragment. And then we'll take the product cards and render them right there. Okay, let's save that, and we'll head over to app.js and let's see if we can import our dashboard. And I'll do this one a different way. I'm just going to write import, and then when I put a D, we see dashboard. If I click on it, it does the rest for us. So you've got 2 options, the drag and drop we did before, or just writing import, the name of the component, and then let it do the rest. Okay, down between the header and the footer, we can render the dashboard. And we do need to pass in some props. We need the username, and we also need the location. And we will actually be adding to that list later. Okay, let's hit save. We can open up the mini browser. And there we are. We have got our 4 product cards. So that is looking pretty good. Now, we're not done because go back to the screenshots. Well, we need these user detail cards as well. We've already got a component for that right here. So all we need to do is bring those in. So back at the dashboard, let's import user detail cards. And as they are actually the main content on that page, they are going to go in an HTML main element. Now we know we want 4 of them. And things do get a little bit strange here because we've got the email address and we've got the username. So I haven't given us a data file like we've got here to map over. I don't think it's realistic that that information would be coming down from some API or something like that. So instead, we're just going to render this one out 4 times. Just to save you watching me do loads of typing, I've actually got a text file right here with everything that we need. So I'm just going to copy that over and I'll just pass those in as props. And if we just check that component, we can see that each one is expecting title and text. That should do the trick, and just notice how we've used curly braces on 2 of these where we are including props, the user email and the user name. Okay, let's hit save. And then when we open up the browser, we've got a bit of a problem. So something has gone wrong. Let's just investigate what's going on in this component. So we have got the user detail card. That should work just fine. But let's check the props that we've got coming in. We've got username and location. We haven't got user email. So let's add that to the list. And let's just make sure in app.js that we're passing that down to the dashboard. We're not at this moment. Let's save and try again. And there we are. Look, that is working just fine. Okay, now we've got that working, I want to show you a really cool Chrome extension. Let's come up here to our Chrome settings, go to extensions, visit Chrome Web Store, and again, we'll search on React, and this is the one we want, React Developer Tools. We're going to add it to Chrome. And now let's go back to our layout and we'll just open up the DevTools. And what we're going to get from this extension is a couple of options right in here. And actually we're not, because I need to do a refresh. And now when I click on these two arrows right here, we'll see two new options, Components and Profiler. Let's just click on Components. And we might just make ourselves a little bit more space so we can actually see our app. So what have we got here? We can actually see the entire React tree. We've got the app, we've got the header. And if we click on one, like I've just clicked on header, we can see the props we've got. We've got location UK, username Tom. If we move on down to the dashboard, we've got our individual product cards. Again, we can see all of our props in here. That is pretty cool. Let's just head up to app. Here we've got the hooks. So we've got all of our state. Let's just change one of these. So one of the benefits of this extension is that we can just make some changes and see re-rendering actually happen live. Right here, we've got the £sign because I've put my location as the UK. Let's change that to US. And when I hit enter, look what happens. We get the $sign instead. And if I scroll right to the bottom, it says here, follow us on Instagram. Let's change my age to 130. And now it says, follow us on Facebook. Take it down to age 1, follow us on TikTok. So you can really see how the state that you change is percolating down through the apps as it's passed down as props. So that can be really, really useful for understanding how an app works and of course for debugging. Now we had another option in here, which was this one, Profiler. And this is quite an advanced one, and you're probably not going to use this anytime soon, but I want to show you quickly and just explain a bit about what it does. What happens is that we can click the blue button to record, and now we can interact with the app. And so because this is basically a static site at the moment, I'm just going to flip back to the components, and then let's make some changes. Let's put the age back to 30 and the country back to UK. And now if we go back to Profiler, I'll stop the recording. And now we get some feedback on how fast our app responded and exactly what happened. So we can see what rendered and how long it took. And that can be really, really useful for seeing re-renders. You might find in a complex app where something's gone wrong that you're just re-rendering the same component thousands of times and it's causing performance issues. Well, this is the tool to help you debug that. As I say, it is quite an advanced topic, not one you're going to use anytime soon, but good to know that it's there. Okay, we're not quite done. I want to go back to VS Code, and I just want to show you two more extensions. Let's go to the Extensions tab, and here I'm going to search for React Tree. And we come across React Component Tree. Let's install that. And I'm just going to close down that tab now. Down here, we got a new option, Build Tree. Let's click it. And look what we get here. We get a similar view of the tree as we actually got in the DevTools. This one is also pretty useful. So imagine you've got a massive app and you're looking at a component. Well, right now, if we go to Dashboard, it's going to highlight it here and you can instantly see how it fits into the tree. Again, let's go back to the File Explorer. I'll take Product Card. And now when I go to the tree, and by the way, we've got a new icon for it right here, I can easily find it in this tree and just see what the parent or sibling elements are. Now, this one I think is quite useful, but there's actually a somewhat better one. I'm just going to put in here React Tree, all as one word. This is the one I want. Let's install that. Okay, we get another option down here, which is Start Tree. Let's click that. And I'm just going to close all of the open files. And it's inviting us to select a file. Let's click on that and we will go to Downloads Urban Nest. Let's just take the top of the funnel, so app.jsx, let's open that. And look, here we get a really nice visualization of the app. And we might just zoom out a little bit so we can see it all. So we've got app.jsx, the 3 components it renders, and the 2 components we've just added to the dashboard. If we click this P icon, which is grayed out in here, that will actually open up all of the props so you can see what's going on. We've got the username here and here, for example. We can see that we passed title and text down to user detail card. You can also change the direction. It might be a bit easier to read left to right than top to bottom. And also you can play around with the layout, which again, in a big app might be useful just to be able to sort of spread things around and see what is where, and perhaps consider some changes, consider making things a little bit more economical. Okay, so we are done. Those are some pretty useful extensions that you can use with VS Code or with Chrome to make your life as a React developer just a little bit easier.